Hello everyone, very good evening. So welcome to the session about the GATE 2024 questions and solutions. So I'm Surendra Reddy, faculty at OHM Institute. So I'm going to explain about the weightage of each subject that we got in today's electrical paper. So you can see here. So aptitude and English covering 50 marks weightage. Mathematics as usually 11 marks. Electrical circuits just like every other year, so we got 9 marks weightage this year. And EMF a little bit reduced. Usually we used to get 6 marks, 7 marks weightage from the past 5-6 years, but this year we got only 4 marks. And the signals and systems, the weightage is being increased. So last year it was around 8 marks only, but this year it was 11 marks. And electrical machines weightage is drastically reduced. So it is usually around 10 to 11 marks weightage, but this year we got only 6 marks from electrical machines. Power systems weightage is significantly improved. So it was usually around 9 to 10 marks and we got 12 marks this year. And the control system, the weightage is like regular years. So we got 9 marks weightage. Measurements weightage is slightly improved. So we use it to get every time 3 to 4 marks weightage, but this year we got 5 marks. Analog electronics, the weightage is just like every other year, 5 to 6 marks weightage. So this year we got 6 marks. So we have to figure out from what topics we got the questions from analog electronics. And digital electronics weightage is been reduced. So it was usually around 5 to 6 marks every year, but this year we got only 3 marks. However, in today's morning paper, digital electronics, in EC paper, digital weightage been increased. Okay. So power electronics, just like every other year, so we got 9 marks weightage. Okay. So on a whole, I can say it is a pretty much balanced paper, except electrical machines, which is usually a core subject for electrical students. That weightage is been reduced, but I can say it is a pretty much balanced paper. Okay. So and majority of the students are saying that the paper is a little bit lengthy. However, it's not difficult. Questions were moderate, easy to moderate level questions, but they were a bit lengthy. So we have to see, okay, how many marks each student were able to answer. Okay. So I'll be starting with the electrical machines questions. So as it is memory based questions, we were not able to collect all the 65 questions that we have. So we were able to cover around 70 to 80% of the paper. So actually machines 6 marks weightage is there, but I was able to collect 5 marks questions. Okay, one mark question I was unable to gather it. So anyway, so whatever the questions available, I'll try to discuss. So let's move to the first question. All right, so this is a multiple choice question, 1 mark model, and you can see this is a question from induction machines subject. So read the problem. A 3-phase 50 Hz 6-pole induction motor runs at 960 RPM. Stator copper loss, core loss and rotational losses of the motor can be neglected. The efficiency of the motor in percentage is what? So very clearly states that stator copper loss, core loss and rotational losses are being neglected. That means indirectly the only power loss that is considered is a rotor copper loss. Okay. So first of all, let us calculate what is the synchronous speed of this machine. So the formula is 120 F by P. So it was a 50 Hz 6-pole machine. So obviously 1000 RPM is the synchronous speed, and machine was rotating at 960 RPM. So you can calculate the slip. So ns minus nr divided by ns. So if I substitute the data, 1000 minus 960 by 1000, so it was 0.04. Okay, that is the value of slip. And one more thing, as stator losses are completely neglected, whatever the input power we are giving to the motor, same power will appear at the air gap as well. So I can say input power is equal to air gap power. Okay. So input power is equal to air gap power. The reason is stator losses are neglected. And once we know air gap power, then what is going to be output power? Output power is equal to mechanical power developed by the motor. Actually, output power should be mechanical power developed minus mechanical loss. This is the exact formula. However, mechanical losses are neglected as per the information given in the problem. So, if mechanical losses were neglected, then output power will be equal to mechanical power developed. Then what will be the efficiency formula? Efficiency is equal to output power divided by input power. So, here into 100, of course. So, output power is mechanical power developed. So, it is mechanical power developed minus, divided by input power, which is nothing but air gap power. All right. But we know mechanical power developed is always equal to 1 minus S times of air gap power. Okay. So, efficiency is equal to 1 minus S times of air gap power divided by air gap power into 100. So, air gap power will be cancelled. So, efficiency is equal to 1 minus S into 100. In fact, if you prepared induction machines thoroughly, you need not to do this entire derivation. You can directly write down this formula because stator losses are neglected, rotational losses are neglected. So, approximate efficiency equation is directly 1 minus S. Okay. So, I did the derivation, but actually you can directly do it. Okay. So that you can save the time. So, what is the value of slip we got? 0.04. Therefore, I am getting 96%. Okay. But I wanted to check once again, is the question is about percentage efficiency or per unit efficiency. So, let us go back. Yes, it is a multiple choice question and you can see the options were in percentage only. So, the answer is 96%. Okay, option D. All right. It is a very simple question. All right. So, let us move to the next problem. This is a question again from induction machines subject, and this question is given for 2 marks and it is also a very easy question. Let us go through it. So, you can read the problem. A 3-phase star connected slip ring induction motor has the following parameters referred to stator. Remember, these parameters were referred to stator. So, stator resistance, stator leakage reactance, rotor resistance, rotor leakage reactance, everything was given. The per phase stator to rotor turns ratio was also given. See, the turns ratio of the machine was also given from stator to rotor. The rotor is also star connected. Okay. The magnetizing reactance and core loss components are neglected. See that magnetizing reactance and core losses are neglected. That means the shunt branch is being neglected, isn't it? Okay. So, to have a maximum torque at starting, the extra resistance that is required in the rotor winding per phase is how much? Okay. So, this is a regular model. Now, let me draw the circuit diagram first. So, let us say this is the stator resistance R1, stator leakage reactance X1, and then we have a rotor resistance, this is R2, a rotor leakage reactance, this is X2. Remember that the question is about to have maximum torque at starting. We know that starting means slip is equal to 1. That is why I am not writing R2 by S. Okay. So, this is going to be the supply voltage. Now, the point is that we wanted to create maximum torque at the time of starting. Okay. So, first of all, what is the generalized equation for electromagnetic torque? So, we know electromagnetic torque is equal to air gap power divided by synchronous speed in radian per second. And if I maintain supply frequency constant, this synchronous speed is usually a constant value. So, therefore, I can write electromagnetic torque is directly proportional to air gap power. So, if I wanted to create maximum torque, indirectly we have to make sure that air gap power is maximum value, isn't it? So, if air gap power is maximum, definitely the torque is also going to be maximum. Okay. Now, what is mean by air gap power? So, we know air gap power formula is equal to 3I2 square into R2 by S. Okay, this is the formula for air gap power. But we are talking about a starting condition. we know at the time of starting slip is equal to 1. Therefore, air gap power is simply equal to 3I2 square into R2. That means indirectly, air gap power is nothing but the power drawn by rotor resistance, okay, at the time of starting. All right. So, if I wanted to maintain this air gap power maximum, indirectly, maximum power has to be transferred to rotor. Understand? If maximum power is transferred to rotor, automatically air gap power will be maximum. If air gap power is maximum, electromagnetic torque is also going to be maximum. Okay, and here I can use maximum power transfer theorem so that I can get the answer easily, right? Most importantly, what is the answer we need? What is the extra resistance we have to add to the rotor so that we can create maximum torque? That means we have to add some external resistance into the rotor. Let's say I am adding an extra resistance of R external. Okay. Therefore, what is the total rotor resistance now? Total rotor resistance means it is the combination of these two resistors. Okay. Already rotor winding has a resistance R2. I am adding an additional resistance so that the total rotor resistance means it is the combination of these two, isn't it? Now apply maximum power transfer theorem here. Okay. So let me redraw the circuit. So this is the stator resistance R1, stator leakage reactance X1, this is the rotor leakage reactance X2, and here we have rotor winding resistance R2 and extra resistance that we have added. Okay. Now this is the supply voltage. Whatever the power is drawn by these two resistors together, that is what, nothing but air gap power. And according to the question, that air gap power must be maximum. So therefore, you have to apply the condition for maximum power transfer theorem. What is the condition? Load impedance must be equal to source impedance, right? So according to maximum power transfer theorem. Okay, so what is the load impedance? R2 plus R external must be equal to source impedance, means we have real part as well as imaginary part. So it is square root of R1 square plus X1 plus X2 whole square. Just to substitute the data. So yes, what is R2 given in the problem? Yes, rotor. R2 means rotor resistance 2 ohm. Stator resistance 3. Both reactances are 2 ohms, right? So it was 2 plus R external is equal to square root of stator resistance 3 ohm and both reactances are 2 plus 2 whole square. Okay. So if I solve this, I will easily get what is the extra resistance required. Okay. Let me do it. Okay. Okay, so according to this, the external resistance must be 2 ohm, isn't it? So the right side factor will become 5 minus 2, 3 ohm, okay? But important thing is that whatever the external resistance I got, according to this calculation, is the resistance referred to stator. Don't forget that, because all these parameters were referred to stator side. But the answer that I need is what is the extra resistance required referred to rotor side. Therefore, what I need to do, whatever the answer I got here, sorry, this is 3, right? So whatever the answer I got here, I have to transfer this resistance to rotor side. Okay. So therefore, what is the resistance referred to rotor side? Let's say R external dash. Okay. So it is simply 3 into rotor number of turns by stator number of turns whole square. Okay. So according to the question, rotor by stator. Let me go back. Yes, stator to rotor is 3:1. That means rotor to stator it is 1/3. Okay. So 1/3 whole square. So 1 3 will cancel. The answer is 1/3, 0.33 ohm per phase. So that is the external resistance we have to add to the rotor circuit so that we can get maximum torque at the time of starting. Remember guys, most of the students will commit a mistake here, because generally when we are discussing about this topic in the classroom, there is a formula SMT. To create maximum torque at the time of starting, SMT must be equal to 1. And what is the direct formula for SMT? R2 plus R external by X2. Okay, I will write here. Yes, SMT is equal to R2 plus R external by X2. So if it is equal to 1, obviously starting torque will be equal to maximum, but this is a wrong formula to use. Why? Because this is the formula valid only if stator impedance is completely neglected. But in this question, stator impedance is not neglected, stator impedance is considered. Therefore, I have gone through the regular process where I have used maximum power transfer theorem. Okay. Last questions. Okay. So let's move to the next question. This is a question from DC Machines, and it's a 2 marks question, numerical answer type. But as per the question, I have observed it is a little bit of ambiguity model. I don't know, because it is a memory based question only. I don't know whether it was written correctly or not, but let's go through it. So a 5 kilowatt 220 volt DC shunt motor has 0.5 ohm armature resistance including brushes. The motor draws no load current of 3 ampere, very clear. Field current is 1 ampere. Core loss and rotational losses are constant. We know core loss and rotational loss belongs to constant losses. What is the line current drawn by the motor while delivering rated load for best possible efficiency? See, there are why I said this question is having some ambiguity, because according to the question which I received, it was given that delivering rated load, that is one word, best possible efficiency, this is a second word. See, best possible efficiency means maximum efficiency, but rated load is another word used. So there is no guarantee that we will get maximum efficiency at rated load. Rated load, maximum efficiency conditions may not be same at the same time. That's why I said while as it is a memory based question, there might be some mistake while writing the question, but I will do it both. Okay. So what if we wanted to find out maximum efficiency case? What if we wanted to find out efficiency at rated load condition? Both we will try to solve. Okay. First of all, I will use the no load data that was given in the problem. First, no load data. What was the supply voltage? 220 volt. Okay, clear. Yes, the motor is drawing a no load current of 3 ampere. That is indirectly the line current. The line current is 3 ampere. Out of that, how much is going to field circuit? Field is carrying 1 ampere. Out of that, field is carrying 1 ampere. So therefore, remaining current will go to armature. So what is the value of armature current? Armature current is equal to line current minus field current. So 3 minus 1, that is armature current 2 ampere. Clear? Now using this no load data, we will try to find out rotational losses first. Okay. Yes. So as it is no load, the input power Vt into IL. So where Vt is 220, IL is equal to 3. So therefore it is 660 watt, isn't it? Yes, 220 into 3 ampere, 660 watt. Now input power was not. Next point, what is armature resistance loss? Armature copper loss, this is equal to 2 square into armature resistance 0.5. So it is 4 into 0.5, that means armature copper loss is just 2 kilowatt. Then what about shunt field copper loss? So shunt field copper loss formula is Vt into ISH. So Vt is 220, field current is 1 ampere, therefore shunt field copper loss is 220 watt. Now I wanted to find out constant loss first. Okay. So what is the formula for constant loss? Constant loss is always equal to total input power during no load condition minus armature copper loss. That's all. Total input power during no load condition minus armature copper loss, because armature copper loss is a variable loss. Okay, so what is the total input power? 660 minus what is armature copper loss? It's not 2 kilowatt, guys, it is 2 watt, right? Okay, fine. So just 2 watt. So 658 watt, that is the value of total constant loss. Constant loss means, remember guys, it is the combination of rotational loss, core loss and shunt field copper loss also. Everything is included. 658 watt. This is constant loss. Now let us find out maximum efficiency condition. Yes, maximum efficiency. Okay, so what is the condition for maximum efficiency? Yes, maximum efficiency can be obtained at a load where variable losses are equal to constant losses. So what is mean by variable loss? Ia square Ra, this must be equal to constant loss. What is the constant loss? We already found 658 Ia square into armature resistance 0.5. So therefore Ia square is equal to 1316. From that, Ia value is equal to one second. Yes, it is 36.27 ampere. So this is the value of armature current at which maximum efficiency can be obtained. So don't confuse here. What is the difference between the given armature current and the answer that we found? See, the given armature current is, that is the current drawn at no load condition. But the answer that I identified is armature current at maximum efficiency condition. Okay, but we are asked to find out only armature current or current drawn by the motor. Yes, what is the line current drawn by the motor? Once we know armature current, what is the formula for line current? Yes, so therefore line current is equal to armature current plus field current. So armature current is 36.27, field current is 1 ampere because it is a constant value, so it is 37.27 ampere. So if the motor is drawing this much current, that means indirectly it will give best possible efficiency. Best possible efficiency means indirectly maximum efficiency of the motor. Understand? But during this condition, there is no guarantee that load is going to be rated value. Okay, there is no guarantee. Rated load may not offer maximum efficiency. If you wish, I can calculate the load also at this particular moment. Okay, so see, how can I calculate the load? Load is nothing but output power. The load at maximum efficiency, isn't it? Load is nothing but output power only. So therefore output power is always equal to input power minus losses, isn't it? Simple formula. Input power means Vt into IL minus losses means combination of constant and variable losses. It is constant loss plus variable loss. Okay, now just substitute the data. What is Vt? 220, and what is the line current value we got? At maximum efficiency line current 37.27. Yes, 37.27 minus what is the constant loss value we already found? 658, and variable loss, can I say simply Ia square into Ra, armature copper loss. So what is Ia value? Ia value 36.27. So it is 36.27 square into armature resistance 0.5 ohm. So if I complete this calculation, I will get the output power value. Let me do it. Okay, so I am getting 6,883 0.64. That means indirectly 6.883 kilowatt. So this is going to be the load power at which efficiency is maximum value. But what is the given machine rated load? If you just wait. If you look at the data, it was very clearly written 5 kilowatt motor. This is nothing but rated load, guys. This is rated load. But this load will not give you maximum efficiency. At what load we are getting maximum efficiency? At 6.88 kilowatt load, we got maximum efficiency. That's why I said there is an ambiguity here. Delivering rated load, maximum possible efficiency, both cannot happen at the same time. So I think it is definitely the question about maximum efficiency only. Therefore, the answer is at what current maximum efficiency was obtained? 37.27. At this particular current, what is the value of load power? 6.883 kilowatt. Okay, that's all. These are the questions I collected from electrical machines subject. So covered 5 marks. There was one more 1 mark question that we can see a little later in case if I collect that question. Okay. Thank you. So I am handovering the session to Hemant sir to discuss the next subject.
Okay. So coming to digital circuits, we have 3 1-mark questions from digital circuits in GATE 2024 electrical paper. So we have got 2 questions right now. The third question I'll discuss it with EMF topic. Okay. So yeah, this is the first question, the first 1-mark question. We have been given a function and we want to implement this function by means of a multiplexer. Okay. So first of all, since this is a 2 variable function, let's write this function in terms of minterms format. So we have the function as f being equal to, this is x y bar plus x bar. Okay. So here x y bar can be written as 1 0, whereas x bar can be written as this is 0, and the other part in fact is kind of don't care, you can say. Okay. So 1 0 in terms of minterm numbers is 2, 0 d in terms of minterm numbers is d can be either 0 or 1. So accordingly 0 0 means 0, 0 1 means 1, right. So finally we can say that x variables becomes equal to, this is sigma minterms 0 1 2. So let's write this in terms of expression format. Minterm 0 is x bar y bar, minterm 1 is x bar y, plus minterm 2 is x y bar, right. And furthermore, if you further expand this expression, we get it as x bar y bar into 1 plus x bar y into 1 plus x y bar x y bar into 1 plus lastly x y into 0. Okay. So we don't have x y term. So whatever numbers you see here, so we have the number here 1 1 1 0. So we have written them in the minterm order. X bar y bar is the first minterm 0, x bar y is the second minterm, x y bar is the third minterm, x y is the last minterm. They should be present here. So 0 1 2 3 corresponds to the corresponding minterms. So for corresponding to 0, we have the value as 1 1 1 0. So here p becomes 1, q becomes so p becomes 1, q becomes 1, r becomes 1, and s becomes 0. That's it. So PQRS values becomes equal to 1110, which is your option D. A very simple question, straightforward question. Okay. Yeah. Next we have again minimization of Boolean function, but the function, if you notice, is given in terms of SOP format. So the approach for this question is, function is given in terms of SOP format. Convert this into function in terms of sum of minterms format. Okay. SOM corresponds to sum of minterms format, and then construct the K-map. Construct K-map, and from K-map now get the minimized SOP format. Okay. So this is a process. So from the sum of products format, we don't know whether the given SOP format is a minimized one or not, and hence we are finding out the minterms first, constructing the K-map, and then finally we are going for the minimization process. Okay. So let's take the function. It's a function of 4 variables, f of p, q, r as well as s, which becomes equal to p bar q bar plus p bar qs plus p q bar r bar s bar plus p q bar r s bar. Convert them in terms of minterm numbers. So to convert this into minterm numbers, we can write this p bar q bar as 0 0 xx. R and s are not there. In place of rx, we have taken xx. P bar qs 0 1. R is not there. X and s is true form 1. Next we have p q bar r bar s bar is 1 0 0. P q bar r s bar is 1 0 1 0. Right. Now write them in terms of numbers. 0 0 xx corresponds to this is 0 0 0 0, and then we have all zeros 1, and then we have all zeros 1 0, and then we have all zeros 1 1 3. 0 1 2 3 are the minterms here. Then here substitute the value of x as both 0 and 1. 0 means 0 1 0 1 5. 1 means 0 1 1 1 7. 5 comma 7 are the minterms. This is 1000 is 8, and then here we have 1010 which is 10. So now we got the function in terms of minterms format. So here the function in terms of minterms format is, okay, so this is sigma minterms 0, 1, 2, 3, then we have 5, 7, 8 and 10. Now the first part is complete. Construct your K-map from this. Okay, so we are going for the construction of K-map. So we'll go for a 4 variable K-map here. So P, Q, R, S are the variables. Minterms are 0, 1, 2, 3. 0, 1, 2, 3. And then we have 5, 7. This is 5, 7, 8 and 10. 8 as well as 10. Okay. Now we can form the groupings. So we'll have here two quads. So one of the quad is a corners. Corners form one quad. Okay. And we can call this quad as, this is Q bar and then S bar. So this is Q bar, S bar, and the other quad is the rest of the 4 ones. So this grouping is P bar and then S. So this is P bar S. So finally what we have to do with respect to these minimized product terms, we have to add them. So from this, I can say that from this expression, in fact, we can write the final answer as the minimized SOP format of the function is f becomes equal to, so we have P bar S one term, one more term is Q bar S bar. That's it. Okay. So from the options we have P bar S, yeah, I think option A, P bar S plus Q bar S bar. A very simple, straightforward routine question this is. Okay. Yeah, so this is about digital circuits, and overall if you ask me regarding the toughness level of digital circuits, we don't have any question which is in fact twisted. We all the questions from digital circuits are straightforward. We got 3 questions and all the 3 questions are very easy questions. Okay. Yeah, so next we have Lakshman sir. Lakshman sir will be discussing the mathematics questions. Okay.
క్వశ్చన్స్ లేదు సార్, యాడ్ చేసుకోవాలి. Now let us solve the questions related to the mathematics. Here we have a matrix A which is defined as 1, 2, 3, 4 whole square. So the matrix A is defined as 1, 2, 3, 4 whole square. We need to find the value of sum of eigenvalues. So we have a formula so we have a property here, sum of eigenvalues is nothing but trace of the matrix. So here we need to find the sum of the eigenvalues of matrix A. So it is indirectly we need to calculate the trace of the matrix A. First we will find the A. A is defined as 1, 2, 3, 4 whole square. So A is equals to 1, 2, 3, 4 whole square can be written as multiplied with 1, 2, 3, 4. So evaluating the value of this matrix A, it will be 1 into 1, 1 plus 3 into 2 is 6, 1 into 2 is 2, 2 into 4 is 8, and 3 into 1 is 3, plus 4 into 3 is 12, and 3 into 2 is 6, plus 4 into 4 is 16. So the matrix A is 7, 10, 15 and then 22. We need to find the sum of eigenvalues, which is nothing but trace of this matrix. Trace of this matrix is nothing but sum of the diagonal elements of the matrix. So the diagonal elements are 7 and 22. So the trace of matrix A is 7 plus 22, which is equals to 29. So the trace of A is 29, which is equals to sum of eigenvalues. So the sum of eigenvalues value is trace and it is equals to 29. So the value of sum of eigenvalues of a given matrix is 29. Answer is 29. Coming to the next question. So again here we have 4 matrices in the options. We need to find which of the following matrix has inverse. So we need to find the matrix which has inverse. So if matrix A has inverse, then mod A or determinant of A cannot be equals to 0. If determinant of A is equals to 0, then A do not have inverse. For matrix A to have inverse, then its determinant should not be equals to 0. Now we will find the determinant of each matrix. If it is not equals to 0, then matrix will be having inverse. If it is equals to 0, then it will be not having a inverse. Starting with this matrix, mod of this determinant of this matrix is 1, 4, 8, 0, 4, 2, 1, 0, 2. I am evaluating the determinant along this column. So which will be equals to 1 into 4 into 2 minus 0 into 2. So 8 minus 0 minus 0 into anything will be 0, 0 into 4 into 2 minus 0 into 8, 8 minus 0 plus along the third element 1 into 4 into 2 minus 4 into 8. So 1 into 4 into 2 is 8 and 4 into 8 is minus 32. So which is equals to 8 plus 8 minus 32 is minus 24. So the value of 8 minus 24 is minus 16 and not equals to 0. So this matrix will be having inverse. Now let us check the other 3 matrices also. Same, we will find the determinant of each matrix. If it is equals to 0, then the matrix will not be having inverse. If it is not equals to 0, the matrix will be having inverse. So the second matrix is 1, 4, 8, 0, 4, 2, 3, 12, 24. Here we can see here row 1 is having elements 1, 4, 8 and row 3 is having elements 3, 12, 24, which is 3 times of R1. So the elements of row 3 are 3 times multiple of the elements of row 1. So these two are identical. So such a matrix determinant will be directly equals to 0, or else you can verify it will be equals to 0. Coming to the third matrix, we have 1, 2, 3, 2, 4, 6 and 3, 2, 9. 1, 2, 3, 2, 4, 6 and 3, 2, 9. Here also we can notice a property. Here we have R1 elements are 1, 2, 3, R2 elements are 2, 4, 6. So R2 can be written as 2 times the R1. So when such a relation exists between two rows, then the determinant of such a matrix will be equals to 0. So even this matrix do not have inverse. And also this matrix do not have inverse. And the last option we have here is, so this matrix do not has inverse, this matrix do not has inverse. And the last matrix is 1, 4, 8, 0, 4, 2, half 2, 4. So 1, 4, 8, 0, 4, 2, and the third row is half 2, 4, half 2, 4. Here also we can find a relation between R1 and R3. You can see here R1 we have 1, 4, 8, R2 we have half 2 and 4. So R2 can be written as half times the R1. So half of 1 is half, half of 4 is 2, half of 8 is 4. When such a relation exists between any two rows or two columns, then the value of determinant will be equals to 0. So this matrix is also do not have inverse. So the only matrix which has inverse is option A. Coming to the next question. So we have a complex function f of z which is equals to cos z plus e z square. We need to find the coefficient of z to the power of 5 in Taylor's series expansion of f of z about the origin. So first we will write to expand the Taylor's series of the given function. So we know that cos z Taylor's series about z is equals to 0 is written as 1 minus z square by 2 factorial plus z power 4 by 4 factorial minus z power 6 by 6 factorial plus and so on. So this is the Taylor's series of cos z about z is equals to 0, about the origin or z is equals to 0 is same. We need to and we will write the Taylor's series expansion of e power z square. We know that e power z Taylor's series about z is equals to 0 is 1 plus z square by 2 factorial plus z cube by 3 factorial and so on. Now we need to find the e power z square Taylor's series about z is equals to 0. So simple, just put z square in the place of z. Put z square in the place of z. So it will be 1 plus z square plus z square whole square divided by 2 factorial plus z square whole cube divided by 3 factorial and so on. Now if I write addition of these two Taylor series will give the Taylor series of f of z. So f of z will be equals to summation of all these terms and summation of all these terms. So if I write 1 minus z square by 2 factorial plus z to the power of 4 by 4 factorial minus z to the power of 6 by 6 factorial plus and so on plus and also these terms 1 plus z square plus z square whole square by 2 factorial plus z square whole cube by 3 factorial and so on. Now we need to find the coefficient of z to the power of 5. If we look carefully, if we look carefully in this expansion, we do not have the z power 5 term, only we have even powers of z. So here we have no coefficient of z power 5, and also if we look at this series, here also the terms are z square, z to the power of 4, z to the power of 6, and so on. Here also we have the even powers of z. Here also we have no coefficient of z to the power of 5. Hence we can say that coefficient of z to the power of 5 is equals to 0, as we do not have any term with z power 5. So the answer for this question, coefficient of z power 5 in the Taylor's series expansion of f of z, which is equals to cos z plus e z square, is 0. So the coefficient of z to the power of 5 is 0. So coming to the next question, we have 4 functions here in 4 options. We need to find which of the following these functions are analytic in the complex plane. So in the entire complex plane, we need to find which of these functions is or are analytic. We will go through each function and decide whether it is analytic or not. Before that, what are the conditions for analyticity? First we will see. For example, if I have a function f of z which is equals to u plus iv, u is the real part of f of z and v is the imaginary part of f of z. For a function f of z to be analytic, we have 2 conditions here. First condition is it should satisfy CR equations, or we can say Cauchy-Riemann's equations. What are the Cauchy-Riemann equations? Dou u by dou x should be equals to dou v by dou y, and dou v by dou x should be equals to minus dou u by dou y. So if I have a function f of z which is equals to u plus iv, where u is real part, v is imaginary part, to be analytic it should satisfy the CR equations. It is the first condition. And the second condition is these partial differential terms should be continuous. So dou u by dou x comma dou u by dou y, dou v by dou x comma dou v by dou y should be continuous. All these 4 partial differential terms should be continuous everywhere. We will take each option, each function, and check whether it is satisfying CR equations, and also whether these partial differential terms are continuous or not, and decide the function is analytic or not. Starting with the first function, we have f of z is equals to e power mod z. So first function we have f of z is equals to e power mod z. So mod z can be written as root of x square plus y square, and also it can be written as e power x square plus y square whole to the power of half. Here if we observe here, f of z is equals to of the form u plus iv, but here we have only real part and no imaginary part. So for this function e power mod z, u is equals to e power x square plus y square whole to the power of half, and v will be equals to 0. Then we will calculate all these terms, dou u by dou x, dou v by dou y, dou v by dou x, and minus dou u by dou y. So dou u by dou x, partial differentiation of this term with respect to x, which is equals to e power x square plus y square whole to the power of half. Coming to this term, partial differentiation of x square plus y square whole to the power of half will be half times x square plus y square whole to the power of half minus 1. I am writing directly minus half, and partial differentiation of this term with respect to x will be 2x. So this is the dou u by dou x. Simplifying it, e power x square plus y square whole to the power of half divided by x square plus y square whole to the power of half. Similarly, if we calculate dou u by dou y, it will be equals to e power x square plus y square whole to the power of half into y divided by x square plus y square whole to the power of half. These are the terms dou u by dou x, dou u by dou y. As v is equals to 0, dou v by dou x is equals to 0, dou v by dou y is equals to 0. So now we will check whether CR equations are satisfied or not. First condition, so dou u by dou x is this term and dou v by dou y is equals to 0. So these two are not matching. So and also these two equations, dou v by dou x should be equals to minus dou u by dou y. So this is also not satisfied. CR equations are not satisfied here. CR equations not satisfied. So we can say that this function is not analytic. So this function is not analytic. Coming to the next function, we have f of z is equals to z square minus z. So this function is not analytic. So second option is f of z is equals to z square minus z. So we have the function f of z is equals to z square minus z. This can be written as x plus iy whole square minus x plus iy. So simplifying these terms, it will be x square minus y square plus I times 2xy minus x minus iy. Separating the real terms and imaginary terms, it will be x square minus y square minus x plus I times 2xy minus y. So here we have imaginary term and real term. So it is u is equals to x square minus y square minus x and v is equals to 2xy minus y. Now we will calculate dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y and check whether the CR equations are satisfied or not. So dou u by dou x, partial differentiation of this term with respect to x will be 2x and partial differentiation of y square with respect to x is 0, partial differentiation of x with respect to x is 1. So dou u by dou x is 2x minus 1. Dou u by dou y will be equals to partial differentiation of this term with respect to y will be minus 2y. Coming to this part, partial differentiation of v with respect to x will be this term, partial differentiation with respect to x is 2y and this term is 0, partial differentiation of y with respect to x is 0. So dou v by dou y, partial differentiation of this term with respect to y will be 2x, partial differentiation of this term with respect to y will be minus 1. So here we have dou u by dou x is equals to dou v by dou y. So dou u by dou x is equals to dou v by dou y and dou v by dou x is 2y, dou u by dou y is minus 2y. So dou v by dou x is equals to minus dou u by dou y. So CR equations are satisfied. First condition is satisfied. Coming to the second condition, all these four partial differential terms should be continuous. If we look at these terms, 2x minus y, minus 2y, 2x minus 1, 2y, all these are continuous only. So two conditions are satisfied. Hence we can say this term is, this function is analytic. So f of z is equals to z square minus z is analytic. Coming to the third function, we have f of z is equals to imaginary of z. F of z is equals to imaginary of z. Imaginary of z is defined as if z is equals to x plus iy, imaginary of z is defined as y. So we have f of z is equals to y. Again we have only real part, so u is equals to y and no imaginary part, so v is equals to 0. Dou u by dou x will be equals to 0, dou u by dou y will be equals to 1, dou v by dou x as it is 0, dou v by dou x 0, dou v by dou y 0. Here also CR equations are not satisfied. Dou v by dou x should be equals to minus dou u by dou y, as it is not satisfied. CR equations are not satisfied. So we can say that this is not a analytic function. So this is not a analytic function. And the fourth function we have f of z is equals to j into real of z. So we have f of z is equals to j into real of z. As imaginary of z is defined as y, real of z is defined as x. So which is equals to jx. So here we have imaginary part and no real part. So u will be equals to 0, v will be equals to x. Calculating dou u by dou x, dou u by dou y, and dou v by dou x, dou v by dou y. Dou u by dou x is 0, dou u by dou y is also 0. Coming to the v part, dou v by dou x is equals to 1, dou v by dou y is equals to 0. Here also CR equations are not satisfied. Hence this function is also not analytic. Not analytic. So this is also not analytic. Even though question is MSQ, multiple select question, out of these 4 functions given, only this function is analytic. Rest of our functions are not analytic. Coming to the next question. We have a 4 differential equations here. Now we need to find which of these following differential equations is or are non-linear. So we need to identify the non-linear differential equations among these 4 differential equations. First we will define what is meant by non-linear differential equation, and thereafter we will identify which of these are non-differential or non-linear or linear. So for a function to be, for a differential equation to be non-linear, or else we can define it as for a function to be linear, for a differential equation to be linear, we have some conditions. What are those conditions? We will see. The first condition is dependent variable and its differential coefficients. So dependent variable and its differential coefficient, they should have degree 1, not order, degree 1. So they should have degree 1. So these are the conditions for differential equation to be linear. Dependent variable and its differential coefficient should be of degree 1. And no multiplication should happen between, dependent variable and its differential coefficients. So the multiplication is not allowed between dependent variable and also its differential coefficients, which means that y, for example, if y is a dependent variable, x is an independent variable, y cannot be multiplied with dy by dx, or else y cannot be multiplied with d square y by dx square, and so on. Even multiplication is not allowed between dy by dx and d square y by dx square, and also multiplication is not allowed between among itself, means dy by dx into dy by dx. This is also not allowed for a differential equation to be linear. And the third condition is no function of dependent variable, which means, for example, in a differential equation, if we have a term like sin y, cos y, this is also not allowed for a differential equation to be linear. So these are the conditions to be satisfied for a differential equation to be linear. First condition is the degree of dependent variable and its coefficient should be 1. No multiplication is allowed among the dependent variable and its differential coefficient. And the third condition is there should not be a function of dependent variable. Now we will cross check with all these differential equations and verify whether given differential equations are linear or non-linear. So coming to the first differential equation, here if we observe t t is a independent variable and x is a dependent variable. So here we have x is a dependent variable and t is a independent variable. Now we will go through all these conditions, and no dependent variable x of t, its degree is 1, and the differential term, its degree is also 1. No multiplication is happening between x of t and dx of t by dt, and also there is no function of x. This is a function of t. Function of t is allowed, function of independent variable is allowed, function of dependent variable is not allowed. So all these conditions are satisfied. This differential equation is linear. So we need to identify which are non-linear. Okay, this is so this is not non-linear, this is linear. And coming to the second differential equation, again we will see the same conditions. X of t, its degree is 1, dx by dt, its degree is also 1, no multiplication is happening between these terms, and also there is no function of dependent variable which is x. T square is a function of t which is independent variable, e power t is also function of t which is independent variable. So this differential is also linear. This differential equation is also linear. Coming to the third differential equation, here we have x of t plus e power dx by dt is equals to 1. Now we will see this differential equation. So we have x of t is equal x of t plus e power dx of t by dt is equals to 1. This is the given differential equation. Again we have x as dependent variable and t as independent variable. Now I will rewrite this differential equation. So e power dx of t by dt is equals to, taking this term to the right hand side, 1 minus x of t, applying log on both sides. So it will be dx of t by dt is equals to logarithm of 1 minus x of t. So here if we observe, this is a function of x which is a dependent variable. This is a function of dependent variable. Hence this differential equation is non-linear. This differential equation is non-linear as it is having a function of dependent variable. In this case x is the dependent variable. Coming to the fourth differential equation, again we will go through the same conditions here. T is a independent variable, x is a dependent variable, x of t the degree is 1, dx by dt the degree is 1, and no multiplication is happening between x of t and dx of t by dt, and also there is no function of dependent variable which is x. Cos t is a function of t, it is a independent variable. Sin t is also a function of t which is an independent variable. So this is also linear differential equation, and this is non-linear differential equation. So among the given differential equation, 4 differential equation, only this option C is non-linear, rest all the differential equations are linear. So the answer to this question is only C. This is also, even though it is an MSQ, the only answer is option C, which is non-linear DE. Coming to the next question, here we have a vector u 2x plus y cap, 2x cap plus y cap plus 2z cap, where x cap, y cap, z cap are unit vectors along x, y, z axis respectively. Okay. We need to find the directional derivative of this function at this point 1 comma 1 comma 1 in the direction of u cap. So we have a direct formula to find the directional derivative of any function at some particular point in the direction of a given vector, which is nothing but, so directional derivative is defined as grade phi, where phi is a given function at point P, into dot product of a cap by modulus of a cap, where a cap is the in which direction we need to find the directional derivative. Here a cap is nothing but u cap, phi is nothing but f, and point P is nothing but 1 comma 1 comma 1. We will evaluate each term by term here and substitute in this formula. We will get the directional derivative of this function in the direction of this u cap. First of all, we will try to find the grade phi or else grad f. So grad f is defined as dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap, and f is defined as, here f is a long function. We have 2 logarithm of xy plus logarithm of yz plus 3 logarithm of xz. Let me rewrite f here. F is equals to 2 logarithm of xy plus logarithm of yz plus 3 logarithm of xz. We need to find dou f by dou x as well as dou f by dou y as well as dou f by dou z. So first we will partial differentiate this entire function with respect to x, so which will be equals to dou f by dou x is partial differentiation of this term with respect to x is 2 into divided by xy into partial differentiation of xy with respect to x is y plus this term is not having x, so partial differentiation of this term with respect to x is 0. Coming to this term, partial differentiation of 3 logarithm of xz, so it will be 3 by xz into z I cap plus dou f by dou y, partial differentiation of this entire function with respect to y. So the partial differentiation of this term with respect to y will be 2 by xy into x, partial differentiation of this term with respect to y will be 1 by yz into z, and the partial differentiation of this term with respect to y will be 0 as it is not having any y terms, into j cap. Finally we need to find dou f by dou z also, so it will be plus this term partial differentiation with respect to z is 0, partial differentiation of this term with respect to z is 1 by yz into y plus partial differentiation of this term with respect to z is 3 by xz multiplied with x into k cap. So this is the grad phi, grad f. Trying to simplify the terms, y gets cancelled, z gets cancelled, x gets cancelled, z gets cancelled, y gets cancelled, and x gets cancelled. The rest of our terms are 2 by x plus 3 by x is 5 by x I cap plus 2 by y plus 1 by y is 3 by y j cap plus, and 1 by z plus 3 by z will be 4 by z k cap, and grade phi at point 1 comma 1 comma 1 will be equals to, just substitute x comma y comma z is equals to 1 comma 1 comma 1. So 5 by 1 is 5 I cap plus 3 by 1 is 3 j cap plus 4 by 1 is 4 k cap. So this is grade f at 1 comma 1 comma 1, and also we need to find this a cap by modulus of a cap. In this case it is u cap. So u cap by modulus of u cap will be equals to 2 I cap plus j cap plus 2 k cap. Now I am writing here in the place of x cap, y cap, j cap, z cap, I cap, j cap, k cap, both are same only. So modulus of u will be 2 square plus 1 square plus 2 square. So it is equals to 2 I cap plus j cap plus 2 k cap, root of 4 plus 1 plus 4 which is root of 9, it is equals to 3. So here we have 2 vectors, we need to find the dot product between 2 vectors. So directional derivative will be equals to, in the place of dou f at point 1 comma 1 comma 1 is 5 I cap plus 3 j cap plus 4 k cap. So 5 I cap plus 3 j cap plus 4 k cap, dot product of 2 I cap plus 2 j cap, sorry 1 j cap plus 2 k cap by 3. So making this dot product between these two vectors, 5 into 2 is 10 plus 3 into 1 is 3 plus 4 into 2 is 8 divided by 3. 13 plus 8, 21 by 3, which is equals to 7. So the value of directional derivative of the given function at point 1 comma 1 comma 1 in the direction of u cap is 7. So the answer of this question is 7. Coming to the next question, we have a function f of t which is defined as maximum of 0 comma t whole square for minus infinity to infinity, for t falling in the range of minus infinity to infinity, where maximum of a comma b denotes the maximum value between a and b. Now we need to find which of the following statements is true. So this is an MSQ. We need to find which of these following statements is true. So finally what we need to find is about the nature of f of t, whether it is differentiable and continuous, and also the nature of its derivative, whether it is continuous and differentiable or not. So its derivative will be f dash of t. We need to find whether it is differentiable and continuous. First we will try to identify what is the given function f of t. So f of t is equals to maximum of 0 comma t whole square. For example, if I am interested in for the positive t values, so t will be ranging from 0 to infinity. If t is greater than 0, the maximum among 0 and t will be only t. So I repeat, t is a positive value, maximum between 0 and positive will be positive only. So the maximum of 0 and t in this range will be t. So maximum of 0 comma t will be replaced by t whole square. So for t greater than or equals to 0, f of t is t square. For t less than 0, so this value will be negative. So the maximum value between 0 and negative will be 0 only. So for t less than 0, f of t will be equals to maximum of 0 and negative value, which is 0. 0 square will be 0. So this is the given function f of t is equals to t square for t greater than or equals to 0, and it is equals to 0 for t less than 0. Finding its derivative f dash of t. So the differentiation of t square is 2t for t greater than or equals to 0, and it is equals to 0 for t less than 0. So here we have two functions f of t, f dash of t. Let us name it as z of t. Now we are finally interested in finding whether f of t is continuous and differentiable, and also z of t is continuous and differentiable. So f of t will be equals to t square for t greater than or equals to 0, and it is 0 for t less than 0, and z of t will be equals to 2t for t greater than or equals to 0, and it is equals to 0 for t less than 0. If I plot f of t, it will be for t less than 0 it will be 0, for t greater than 0 it will be t square. This is f of t. Coming to the z of t, it is 2t for t greater than or equals to 0, and it is equals to 0 for t less than 0. Now here we have important points here. For a function to be continuous, so for any arbitrary function f of x to be continuous, it should not have any break. For a function, any arbitrary function f of x to be continuous, it should not have any break. For a function, any function if to be differentiable, it should not have a sharp turn in it, should not have sharp turn. So we will see with the definition also for continuity and differentiability. This is a shortcut to find whether the function is continuous or not, and also whether it is differentiable or not. If we look at this function f of t, it is not having any break. Break means a vertical line. For example, if I have a function like this is a vertical line, this is a break, this function is not continuous. If I see this f of t, I am not having any break here, so this is continuous. Coming to this function g of t, here also I cannot see any vertical line, or else I cannot see any break, so this is also continuous. Coming to the differentiability, so for a differentiability it should not have any sharp turn. So the function behavior is changing at this point 0, but it is not having a sharp turn, it is having a smooth turn only at t is equals to 0, so it is differentiability. Whereas coming to this function at this point t is equals to 0, it is coming up to point 0 in this way and taking sharp turn and going in the along 2t, so it is having a sharp turn. So at t is equals to 0 it is not differentiable, so g of t is not differentiable. So we can say that f of t given function is continuous as well as differentiable, but its derivative, which is g of t, is continuous but not differentiable. So coming to the options, f of t is differentiable, yes it is, and its derivative is continuous, yes this option is correct. F of t is differentiable, this is correct, and its derivative is not continuous, so this option is not wrong as its derivative is continuous only. Coming to the third option, f of t is not differentiable, so it is not wrong, it is not true as f of t is differentiable. Coming to the fourth option, f of t and its derivative are differentiable, no, its derivative is not differentiable, but f of t is differentiable, so this option is also wrong. The only option which is true is f of t is differentiable and its derivative is continuous. We can also verify with the definitions, we will also see that part also. So we have f of t is equals to t square for t greater than or equals to 0, and it is equals to 0 for t less than 0. So for a continuity we have three conditions to be satisfied. We are interested in finding the continuity and differentiability at this point. Why? Because rest all points the nature of function is not changing. At only t is equals to 0 we are interested in finding continuity and differentiability. So for a continuity the three conditions are f of 0 to be defined. Yes it is defined, f of 0 is equals to 0. The second condition is limit should exist at that point. So limit x tends to 0, f of x should exist. And the third condition is limit value should be equals to f of 0. So if these three conditions are satisfied, then f of t or else f of x is continuous. So we have first condition, f of 0 is equals to 0. Now we will find the limit. So finding limit will have two parts, left limit as well as right limit. So the left limit is defined as limit h tends to 0, f of a minus h. In the place of a we have x is equal, in the place of a we have 0, as we are interested in finding the continuity at x is equals to 0. So f of 0 minus h, this is the left limit. Right limit is limit h tends to 0, f of 0 plus h. H is a positive number, minus h will be definitely a negative number. So for negative t, f of t value is directly 0. So f of minus h is negative, so the function value will be directly equals to 0. So the left limit is 0. Coming to the right limit, limit h tends to 0, f of h. H is a positive here again. So when h greater than or equals to 0, f of h will be equals to h square. So which is equals to limit h tends to 0, h square, which is equals to 0. So the limit value is, left limit is equals to 0, right limit is equals to 0. That means limit exists and the limit value is 0. The limit value is 0. So this value is 0. is equals to f of 0 value is also 0. So all these three conditions are satisfied. So f of t is continuous at x is equals to 0 and also everywhere it is continuous. Continuous at t is equals to 0 and f of t is continuous everywhere. For differentiability, f of t, for differentiability we need to verify its left hand derivative should be equals to right hand derivative. If these two are equal, then we can say f of t is differentiable. So left hand derivative is defined as limit h tends to 0 f of a minus h minus f of a divided by minus h, and its right hand derivative is defined as limit h tends to 0 f of a plus h minus f of a divided by h. Here we are interested in finding the differentiability at t is equals to 0, that means a is equals to 0. So this will be reduced to limit h tends to 0 f of minus h minus f of 0 divided by minus h. F of 0 is 0, so this term goes to 0. F of minus h is positive, minus h is negative. So f of negative will be equals to 0. Here the definition we can see f of t will be equals to 0 for t less than 0. In the place of t we have minus h which is negative, so this value will be 0. So limit h tends to 0, 0 minus 0 by minus h which is equals to 0. Coming to its right hand derivative part, limit h tends to 0, a value is 0, f of h minus f of 0 divided by h. F of h for positive h which is equals to h square, f of 0 value is 0 divided by h, limit h tends to 0. Limit h tends to 0, h square by h is h, limit h tends to 0, h will be equals to 0. So the value of left hand derivative is 0, the value of right hand derivative 0. So f of t is differentiable at t is equals to 0, and f of t is differentiable everywhere. Similarly, if we calculate I am doing it fast for z of t. So z of t is defined as 2t for t greater than or equals to 0, and it is 0 t less than 0. So z of 0 will be equals to 0 as it is defined. Finding the left limit and right limit, limit h tends to 0, z of 0 minus h, as h is negative it will be equals to 0. Limit h tends to 0, right hand limit, z of 0 plus h which is equals to limit h tends to 0, g of h will be 2h which is equals to limit h tends to 0, 2h is 0. Left limit is equals to right limit and it is equals to z of 0. So z of t is continuous. Coming to the differentiability part, again we need to verify whether its left hand derivative is equals to right hand derivative or not. If it is equal to 0, then it is differentiable. If it is not equal, then it will be not differentiable. So left hand derivative is limit h tends to 0, z of 0 minus h minus z of 0 divided by minus h, and the right hand derivative is limit h tends to 0, z of 0 plus h minus z of 0 by h. Z of 0 value is 0, z of 0 value is 0, z of minus h. So h is a positive, minus h will be negative, so this term will be equals to 0. So limit h tends to 0, 0 minus 0 by minus h which is equals to 0. Left hand derivative is 0. Coming to the right hand derivative, limit h tends to 0, g of h is defined as 2h for h positive values, so it will be 2h minus 0 by h. So limit h tends to 0, 2h by h, h gets cancelled, right hand derivative is equals to 0. If we carefully observe here, left hand derivative value is 0 whereas right hand derivative value is 2. So left hand derivative is not equals to right hand derivative, hence we can say that z of t is not differentiable, not differentiable. So from the formulas also we have concluded that f of t is continuous and differentiable, and z of t is only continuous but not differentiable. So hence f of t is differentiable and its derivative is continuous is the only correct option. Coming to the next question. So here we have a function f of t whose second derivative is positive for all t. So look at it carefully. F of t is a function whose second derivative is positive for all t. That means f double dash of t is greater than 0 for all t. So this is the given first condition. Now we need to find which of these statements are true. This is a very good question which is on concept basis. So the condition is f double dash of t is greater than 0. We have a concept of strictly increasing function which tells us f of t is strictly increasing function. F of t is strictly increasing function if f dash of t is greater than 0 for all t. So we have a concept of strictly increasing function. F of t will be strictly increasing function if f dash of t is greater than 0 for all t. So from this definition we can conclude that f double dash of t is greater than 0 for all t. We can conclude from this condition f dash of t is strictly increasing function. So by using the strictly increasing function definition and the given condition is f double dash of t is greater than 0 for all t, we can say that f dash of t is strictly increasing function. Now coming to this part, what is meant by strictly increasing function? When you move from left to right along the t axis, f dash of t value will be continuously increasing. It will not be going constant, it will be not going downwards, it will be continuously going in the positive increasing direction, which means let us see some. So f dash of t should be continuously increasing when you move from left to right. So here we have three cases. It may start as a positive value at minus infinity and go to the reach also positive value at t tends to infinity. So irrespective of any value, we have one case which starts at positive at t is equals to minus infinity and goes to positive infinity at t is equals to infinity. We have the second case which can start at negative value and go to positive value when t tends to infinity. The only condition is it should continue when you move from left to right, it should increase. That is the definition of strictly increasing function. And the third case is it may start negative value when t is equals to infinity and it may end some negative value at t is equals to infinity, but it should be continuously increasing only. So third option is here. So we have three options here. It may start as positive value at t is equals to infinity and end up being positive value. It may start at negative and end up being positive. It may start at negative and also may end at negative value. So here we have three conditions. Now coming to the options, now we will try to disprove the each statements. If we cannot disprove, then that statement will be true. So the first condition is the minimum value of f of t cannot be negative. So the statement says that if this is the condition, the minimum value of f of t cannot be negative. Now I will try to take a function f of t which will be satisfying this condition and also will be negative, so that this statement gets disproved. So let me take f of t is equals to t square minus 2. So f of t is equals to t square minus 2. So f dash of t is equals to 2t, f double dash of t is equals to 2, which is greater than 0 for all t ranging from minus infinity to infinity. For minus infinity to positive infinity. So I am having a function f of t which is t square minus 2, f dash of t is 2t, f double dash of t is equals to 2, which is greater than 0 for all t. So my function f of t is satisfying this condition, and if I find the function at t is equals to 0, so f of 0 will be equals to 0 square minus 2, which is negative value. So I found a function which is having negative value but satisfying these conditions in the question. So these statements cannot be true. Minimum value of f of t cannot be negative is false. It can be negative satisfying this condition. So this statement cannot be true. Coming to the second condition, f of t cannot have two distinct local minima. F of t cannot have two distinct local minima. Coming to the definition of local minima. So what is meant by local minima? At a particular point, f dash of t should be equals to 0, and also f double dash of t should be greater than 0. For a function f of t, if these two conditions are satisfied, then it will be having a local minima. Now the statement says that it cannot have two distinct local minima. Now we will check here. So for a local minimum, f dash of t should be equals to 0, f double dash of t should be greater than 0. So for all these kind of functions, f double dash of t is greater than 0. This condition is satisfied. Whereas f dash of t is equals to 0, it is getting satisfied for this condition. It is not getting satisfied for these two conditions, but one function is enough to disprove the statement. But if we look carefully, only at one point, we need not bother about the which point, but at only one point, this f dash of t is equals to 0. As f dash of t is strictly moving from negative value to positive value, it cannot turn and come back down, and also it is strictly increasing. It will increase when moved from left to right. So it can have only one point where f dash of t is equals to 0, where it can meet x axis only once. But the statement says there are two such points. Statement says f of t cannot have two distinct local minima, which is true. F of t can have only one local minima but cannot have two distinct local minimum. So this statement is true. So I repeat here, for a local minimum, f dash of t should be equals to 0 and f double dash of t greater than 0. For all these cases, f double dash of t is greater than 0, but only for this case f dash of t is equals to 0, and that too only at one point it can become 0. At 2 points it cannot be equals to 0. So this statement is satisfied. F of t cannot have two distinct local minimum. Coming to the third condition, f of t has at least one local minimum. So again I will take a function f of t which will disprove this condition also. So f of t has one local minimum. So I will take f of t is equals to e power t. So f dash of t will be equals to e power t, f double dash of t is equals to e power t. So f double dash of t is greater than 0 if you put any t. Only at t is equals to minus infinity it will become e power minus infinity to 0, but t falling any in this range, f double dash of t is greater than 0. So my function f of t is satisfying the condition given in the question, and f of t is equals to e power t. The statement is it will be having at least one local minimum. So the function f of 2 to have a local minimum, its f dash of t should go to 0, and also f double dash of t should be greater than 0. but f of t is f dash of t, which is equals to e power t, is not equals to 0 for any t. F dash of t is equals to e power t will not go to 0 for any t lying in the range of minus infinity to infinity. So it is not having any local minimum. So the condition says that f of t has at least one local minimum, which is not true. I have a function f of t is equals to e power t which satisfies this condition and also has no local minimum. Coming to the fourth condition, f of t has at least one local maximum. So to have local maximum, the condition is f dash of t should be equals to 0 and f double dash of t should be less than 0. The condition here is for f of t, f double dash of t is always positive. So this cannot happen, f double dash of t cannot be negative. So this condition is also not true. The only condition which is true is f of t cannot have two distinct local minimum. This is a very good question which is related to calculus. So these are the questions from mathematics. Now Hemant sir will take.
Okay. So next again we'll look at the remaining question of digital circuits and also questions from EMF. Okay. Yeah. Okay. So this is a 2-mark question, multiple choice question. So the initial value of z is 1. So we have been given that this z value becomes equal to 1. Yeah. So z becomes equal to 1. And furthermore, yeah. And you are supposed to find out the state of s as well as the state of z after one clock pulse. So this is the task for you. Okay. So we'll take the present state and then on the basis of this we'll find out the present input also, and then we'll find out what is the next state. Okay, so this is one single clock pulse analysis, so it shouldn't be a big problem for us. So initially q value, which is also equal to z, becomes equal to 1. Okay, and on the basis of that the 1 is fed back to this location. We have XOR gate here, 1 XOR 1 XOR 1, xy values are already equal to 1 here, and hence what is the value of s? The value of s, okay, s becomes equal to XOR gate simply counts the number of ones, and if the number of ones are even, output is 0, odd, output is equal to 1. Okay, so we have 3 ones, odd number of ones, output is equal to 1. Okay, and then what is the next state? So this is entirely before the application of the clock. This is before the application of clock. So this analysis is before the clock. And then we'll also find out what are the values after the application of clock. Okay, so we have to find out also what is the state of your S signal after the application of the clock. So I'll take also here the next set of inputs in fact, and the input we are concerned about mainly is nothing but D, which is also equal to S. Okay, yeah, so the next state is nothing but, see, the present input is S equal to 1 means D is also equal to 1. You give a clock, so whenever you give a clock, output becomes equal to simply the input. So the next state becomes equal to 1. Okay, and what is the next set of inputs? See, whenever you have the Z input being equal to 1 anyway, output is 1 means again that is fed back to this location and state remains to be equal to 1. So there is no change in the state of S as well as also the output. Okay, that is Z. So here we have S and Z both being equal to 1. So the state will not change because the moment this is 1, output is 1 after the application of the clock. So the state of your Z is not changing. When the state of the Z is not changing, the rest of the state of your circuit remains constant. Okay. Yeah, so this is again fairly simple question, nothing great we have. So next we look at questions from EMF subject. Yeah, I think this was covered by, yeah, this is a differential derivative, directional derivative question which is already covered. So let me remove this. See, this is one of the questions that I do in the class regularly. Okay, if you look at your class notes also, you can see this question. So we have some magnetic field. So we have some magnetic field expression. Sorry. And the magnetic field expression is given by some 1 by r cube r cap p cos theta plus sin theta theta cap. So given this expression of magnetic field intensity, we are supposed to find out what is the value of p. Okay. See, whenever it is given to us that we have magnetic field, if h bar is magnetic field, then the divergence of any magnetic field should always become equal to 0. So divergence even for the given field has to be equal to 0. So all you have to remember is the expression of divergence in spherical coordinate system. So in spherical coordinate system, expression of divergence is given by, this is 1 by r square sin theta dou by dou r first term of r square sin theta times h r first term plus dou by dou theta of r sin theta times h theta. See, I am not taking the last term because we don't have any phi terms here. The last one is dou by dou phi of something, and that something we don't care because we don't have any phi terms. Basically, we have r times here h phi, but in this given question, h phi is equal to 0. So we can remove that portion. Okay. So here h phi is equal to 0. What is the value of hr? The value of hr is nothing but p cos theta divided by r cube. So this is p cos theta divided by r cube. And what is the value of h theta? The value of h theta is sin theta by r cube. So this is sin theta by r cube. Okay. So r square r cube. So overall this expression becomes equal to, after minimization we can write it as 1 by r square sin theta into dou by dou r of, see, sin theta and cos theta we can write it as, in fact we can leave it as it is in fact, and then we have r cube divided by r square divided by r cube being equal to 1 by r. So we have p cos theta divided by r one term, one more is dou by dou theta of, so we have sin square theta, r by r cube is 1 by r square. So we have sin square theta divided by r square. Okay, and ultimately this has to become equal to 0. So that's what we have taken as a initial condition. So when we solve this function, we can send this 1 by r square sin theta to the other side. It becomes 0 anyway. And then we can take dou by dou r. First one is dou by dou r of p cos theta by r. So it's basically differentiation of 1 by r. Differentiation of 1 by r is minus 1 by r square. So let me write that. So we have p cos theta into minus 1 by r square, one term, plus, and I'm sorry, I think we have one more term. We also have sin theta term here. So, into also sin theta, and hence, so it is sin theta into p cos theta into minus 1 by r square. The next term is a differentiation of sin square theta with respect to theta is nothing but 2 sin theta cos theta by anyway r square. So this is 2 sin theta cos theta divided by r square, and this should become equal to 0. Okay. see, I can take this sin theta cos theta. Sin theta cos theta is gone. 1 by r square and 1 by r square, you can send it to the other side, cancelled out. So all we have is here we have p minus or minus p plus 2 becomes equal to 0, and hence p becomes equal to 2. Okay, so this is a very commonly given vector field, which I usually discuss in class also. If you look at your class notes, like I told, this exact example was there in your class notes. Okay, yeah. Next. I'm sorry. So here we have been given charges, and we have to find out the value of electric field intensity. Okay, the value of alpha for the electric field intensity to be 0 at a certain point. The point is 0, 0.5, 0, and the point charges are located at minus 1, 1, or minus 1, 0, 0. So okay, we'll draw the diagram here to get a better picture of this question. So we have, let's assume I'm taking xy plane. See, if you look at all the options have z value 0, or all the points have z value 0. So whenever z value 0 means, what is that plane? The plane is xy plane. So I can do the entire discussion only on xy plane. I don't have to bother about anything else. Okay. Yeah, so this is x-axis, this is y-axis, and where are the points located? The points are located at minus 1, 0. So this is the first charge. So this is minus 1, 0. Anyway, this is xy plane, and hence z by default is 0. And here we have a charge of value q, and then we have 1, 0. This is 1, 0, second point. And the last point is located at 0, minus 1. Okay, so 0, minus 1 is somewhere here. So this is 0, minus 1. Okay, and then the location where the field has to become equal to 0 is, this is the point of interest. So this is the point of interest, which is and by the way, I forgot to mention that here also we are having the charge as q, but here we have the charge as alpha q. Okay, and this is the point of interest. At this point of interest, we want to make sure that electric field intensity is 0. Okay, see here, all you require is only one single formula, that is nothing but what is the electric field intensity at a particular point due to a charge. Okay, so let us see what is the generalized expression for that formula. So we want electric field intensity at a point P due to a charge Q. Charge Q is located at, let's assume, point Q. Okay, or P is there. Okay, so let's assume the location of point Q is P0. Okay, so in this case the expression is given by, this is Q divided by 4 pi epsilon r minus r naught bar divided by the magnitude r bar r minus r naught bar, in fact whole cube. So this is a generalized expression. So we want electric field intensity at a certain point to be equal to 0. Okay, so the point of interest has what position vector? And by the way, in this formula, r bar corresponds to this is the position vector of point of interest. So in this case, the point of interest is the point P. Okay, and here r naught bar corresponds to the position vector of the charge location, which is nothing but Q. Okay, Yeah, the moment you have the point, you can always find out the position vector. And like this, we'll have 3 electric fields, and summation of all these electric fields has to become equal to 0. Okay. So, what is R bar? What is R1 bar? What is R2 bar? And what is R3 bar? So, these are the position vectors of point of interest, charge, first charge, second charge, and third charge. So, for that, all you have to look at is the location of the point. First charge, second charge, third charge, point of interest. Point of interest has what location? This is 0, 0.5. Okay. So, what is the position vector of the first charge? Minus x cap. Second charge plus x cap. Third charge minus y cap. And the point of interest 0.5 y cap. So, let me write all these expressions. Yeah. R bar is equal to, this is minus x cap plus x cap minus y cap plus 0.5 y cap. Okay. So yeah, these are the position vectors of all the points. Now on the basis of this, the next thing is calculate R bar minus R1 bar, R bar minus R2 bar, R bar minus R3 bar, R bar minus R4 bar. Okay. So when you calculate this, I'll write this simply as a point again. Okay. R bar minus R1 bar. R bar is I'm sorry, by the way, point of interest is this, no? Right. Okay. I'm sorry. My bad. So this is the point of interest. The point of interest has position vector as, this is 0.5 y cap. R1 bar first charge has a location of minus 1 x cap plus x cap, and then the value of R3 bar is equal to, R3 bar is the point below, is minus y cap. Okay. So R bar minus R1 bar, in the first case we'll have to take the difference of this, x value becomes 1 and y value becomes equal to 0.5. Okay. Next, R bar minus R2 bar. R bar minus R2 bar has what value? X is minus 1 now, and y value becomes equal to 0.5. Okay. R bar minus R3 bar. R bar minus R3 bar is 0.5 minus of minus 1 is nothing but 1.5. Y value is 1.5, x value 0. So this is 0, 1.5. We don't have any R bar minus R4 bar. That's it. The moment you get this, your problem is more or less complete. So in the last case, you have to write the expression for E bar at the point P. So E bar at the point P is given by EP1 bar plus EP2 bar plus EP3 bar. That is the electric field at the point P because of charge Q1, Q2 and Q3. In all the cases, 1 by 4 pi epsilon can be taken common. And in the first case, the charge is given by Q into the vector. The first vector is R bar minus R1 bar given by 1, 0.5. So basically 1, 0.5 is, this is x cap plus 0.5 y cap divided by magnitudes, can say whole cube. Magnitude is nothing but square root of 1 square plus 0.5 whole square. The second one is again charge Q. And what is the second direction vector? The second direction vector is minus 1, 0.5. So minus x cap plus 0.5 y cap divided by same magnitude 1 square plus 0.5 square, in fact whole cube, denominator is this whole cube, plus lastly we have alpha cube. Y value, what is the y value here? The y value is 1.5. So this is 1.5 y cap divided by magnitude is 1.5 only whole cube. Okay. See, we wanted this electric field, to be equal to 0. This should become equal to 0. if you notice here, the component already got cancelled out. Component already cancelled out because we have magnitude minus magnitude, you don't do it. So this part gets cancelled. This what we have plus point, but and q by magnitude this point point
Hello everyone, welcome to Om Gate Institute. So myself Amarnath Dimani, faculty for Aptly Pure Maths and Reasoning. So I hope everybody has written the GATE examination of EEE department very well. So I will say all the best for your results, and let us see the explanation part of aptitude, the questions given in EEE examination of GATE 2024. Let us see a question here. P and Q have been allotted a hostel room. So there are two persons, P and Q. For them, a hostel room was allocated with 2 beds. Okay. A study hall and an almirah. Fine. So 2 beds, 1 almirah and 1 study hall. Okay. P is an avid bird watcher and wants to sit at the table and watch birds outside the window. Okay. So that avid bird watcher means who is very much keen in looking something. Okay, right, good. So sit at the table means the study table and watch birds outside the window. From the window, it looks outside and observes the world and the birds. Q does not mind that as long as his bed is close to the ceiling fan. Means he is saying that Q has no problem, or he doesn't have any other problem if he get a bed which is close to the fan. Okay, fine. So next one, which one of the following arrangement suits them the most? Okay, suits them the most means the room structures he is giving in 4 options, and which is the best fit he is asking. Okay, what I can tell you is, first of all, what I will check is on the study table or table the bird will sit and it should be in a state to observe the world. Is it correct? So if the bird is in this one, suppose this is the option, this is the place, from the window it can observe because this is the window, right? Okay, this option is fine for me. So coming to here, the table is here. If the bird sits on any of this place, it's unable to see the world from the window, so that is not. Okay, of course, even if the table is here, anywhere if it sits, it's difficult to see the world, so that is not. So if the bird is here, yes, it can see the world. So these two are happy. So there are only 2 conditions. Number 1 is the bird should watch the outside world. Okay, and the second one is the person Q should get a bed which is close to the fan. So fan, bed, so close. Okay, fine. This arrangement. So I am fixing answer is A. If you want, you can check it. So for the fan, bed is far away, so that is not. So answer is which option? A is the right answer. Okay, good. So the next beautiful question. Okay, arrow denotes the increasing order of intensity. Then the meaning of the word talk, shout, scream, okay, is analogous to please, blank, pamper. Which one of the given option is appropriate to fill blanks? Okay, this comes under general English. Okay, let us see what he has given. This arrow increases the intensity, order of intensity. Observe that, talk, I will speak with you. This is known as talking. I will shout. Hope you understand what is shout. And scream. Okay. So that means the level of intensity is increasing. Fine. Similarly, please, blank, and pamper. Without seeing the word pamper, if you observe the please word, by default you will feel that please give me that, please do it, please favor me, etc., etc. We will think like that, right? Please means that is one case. Okay, means requesting others. The other meaning of please is, so with the pleasure I will do it. That also comes from please only, right or wrong? Okay, pleasing. Okay, I was pleased with his request. Pleased means satisfying. Okay, this is also another meaning of please. By saying the word pamper, you can. So observe, I am here or you are there. I want to say that please means satisfactory, right or wrong? Okay, satisfactorily I can speak with you. What about pamper? Pamper means whatever uses, yes, exactly. Yeah, it's simply we can say that, right? So to the bosses, the employees will do that, right or wrong? So that is the one. Okay, to the girlfriends, the boyfriends will do it, right? That is known as pampering. Means whatever they say, yes, you are absolutely correct. Means you are much satisfying, overwhelming them. That is known as pampering. So please pamper, in between the word, if you observe the options, flatter, frizzle, flutter, and fritter. Okay, so frizzle and fritter you can already avoid. The words that you will get in your mind is flutter and flatter. Okay, so in general people will think flutter and flatter. When you see both the words simultaneously, you will get confused. Okay, so separately if you observe, yeah, okay, you will feel. So flatter means I am flat. If you say something, okay, so suppose when I am entering into the classroom, students has given standing ovation for me, I was flat with that. Flat means I'm very much satisfied. So meanings to this one. What about this flutter? Flutter means a person who flirts, means who tries to satisfy with false information, is known as flutter. Okay, even though the girl is very much dark, we will say that you are extraordinary, most beautiful, etc., etc., etc. That is known as fluttering. Hope you understand. It is not real, it is untrue. But coming to flatter, that is the absolute word, because many times we'll use that flat, right or wrong? That flat means that I'm fully satisfied, I'm very much happy with it, right or wrong? So that's why please, flatter and pamper is the words that we can observe here. Okay. A shopkeeper buys shirts from a producer and sells them at 20% profit. A customer has to pay 3,186 rupees including 18% taxes per shirt. Okay. At what price did the shopkeeper buy each shirt from the producer? Okay. Right now, observe the question. What we can say is, suppose I am the shopkeeper, I bought it at, okay, so I bought it from the producer and sold at 20% profit. Means my cost price is CP, suppose. I am selling for 20% profit. Means my selling price is 120 by 100 into CP. Actually, I will say this is my selling price. But what happens? I have to pay GST, right? How much it is? 18% is the taxes. Tax will be levied on the selling price, the price at which I am selling. On that I will take the tax. Means on this entire one, I'll take a tax of 18%. Means 100% is the selling price. I'll ask 18% GST. Okay. So why? Because this is my cost price. I'll say that this is my profit. You have to pay me this amount. Okay. This is my deal. But this amount will be the tax that you have to pay to the government, right or wrong? That's why on the selling price, this 18% GST will be levied. It means this selling price is 100% and 18% is the GST, altogether 118%. So 118 by 100. Okay. So this is the total amount that the customer has to pay. He said that that amount is equal to how much? 3186. How much it is? 3186. Okay, good. Now let us start simplifying. You'll get directly the cost price value. Okay, fortunately you have the LO of calci, right? So happily you can simplify in the calci. The answer will be 2250. What's the answer? 2250. Right. So the next beautiful question. A surveyor has to measure the horizontal distance from her position to a distance reference point. Okay. So this is the one. I want to observe the horizontal distance from a reference point called, this is the one. Okay. So this distance I want to keep it in your brain. Okay. Next one. He said that using her position as a center, a 200-meter horizontal line segment is drawn with 2 points A and B. Okay. So taking, this is the point I'm observing, right? So zooming means I will zoom like this by taking A and B, 2 lines. Okay. And the distance AB is 200 meters, means this is 100 and this is 100. Zoom means it will zoom on both the directions at equal distance, right? That's why this is 100, that is 100, total is 200. Okay, now he said that A, B and C are not collinear. Yes, A, B and C are not collinear. Superb. Right. Each of the angles, angle CAB and angle CBA are measured as 87.8 degrees. Angle CAB, okay, means this is, and angle CBA, both measures how much? 87.8 degrees. Okay, 87.8 degrees. And of course, even from this statement also we can say that this is 100 and that is 100. Why? Because if you observe ABC is a isosceles triangle, because 2 angles are equal. If 2 angles are equal, automatically what we can say? Okay, so if you draw a perpendicular from here to here, okay, it bisects the opposite side, right? It acts as both altitude and internal angular bisector, perpendicular bisector and median, right or wrong? That's why that will be bisected, and 100, 100, this angle is 90 degrees. Now the question is, right, the distance in meters of the reference point C from the position is nearest to, that means this distance is nearest to how much he is asking. Okay, observe that from this angle, okay, I need the opposite side. For this it is the opposite side, right? Okay, the opposite side I am assuming to be A. Okay, I know the adjacent side is how much? 100. Opposite and adjacent both are, both we can use only in tangent, tan, right? So now I am going to tan B. Okay, there's nothing but A opposite side, tan means opposite by adjacent, right? So A by 100. So what is the value of B? 87.8 degrees. Okay, 87.8 degrees. Okay, now, so what we can observe is tan value, if you know, the game is over, right? Okay, since you have the calci yellow, you can happily go through the value. Its value is 26.03 something something you will get. Okay, this is equals to A by 100. Okay, if you cross multiply, A will be 2603. Okay, so that is the distance, right? So happily answers which option? A is the answer. Okay, so here the tan of 87.8 degrees matters a lot. Since you have the scientific calci, happily you can calculate. Okay, good. So the next beautiful question. In the given text, the blanks are numbered from 1 to 4. Select the best match for all the blanks. Okay, we'll call that a closed list, right? Okay, observe that. Following a row 1, the shopkeeper, means this is the missed one, there we have to write some word. Okay, shopkeeper, the prices of blank, the prices of a frying pan. The cook stood blank in a row to withdraw cash blank the ATM booth. Okay, good. Now we have to observe that. So first of all, most of the people will think of what is the meaning of row. Row means this is a row, right or wrong? Okay, that is a common idea that they will get. Automatically, they are unable to answer this question. Here, the word row decides the meaning of the given context. Row means, of course, whatever you said is correct. The other meaning is dispute. What's the other meaning of row? Dispute. Now observe with that, following a dispute, the shopkeeper means with the shopkeeper. So the dispute is with the shopkeeper. So first one is with, because the words that he has given is over, at, with. Okay. Following a dispute with the shopkeeper, meaningful. Following with a dispute over the shopkeeper is not proper. Okay. Following a dispute at the shopkeeper is not meaningful. So automatically with. So these two options were ruled out. Now these two. Okay. So following a dispute with the shopkeeper over the price of a frying pan. Why the dispute was happened? Over the price of a frying pan. So the quarrel or the discussion is regarding the price of the frying pan. Okay. So the cook stood in a row to withdraw cash at the ATM booth. Okay, this you can easily identify, right? We will draw the money at the ATM booth. So these two only, the one is easily clear, you can understand, right? Okay, stood in a row to withdraw. Okay, understand, stood, right? Stand, past form is stood. So he already stood in a row, okay, in a row to withdraw the cash. Hope you understand. Regarding the frying pan, okay, he want to buy it. So there is a quarrel behind it between regarding that. Okay, and to buy it finally, he is in a row to withdraw the cash. Hope you understand, right? So answer is D is the answer. Right. So this is a graph. Okay, we have to understand the graph very well. Okay, observe that. Okay, the chart below shown the data of the number of cars bought by millennials and generation X people in a country from the year 2010 to 20. Okay, actually this is 2010, this is 2015, and this is 2020. Okay, good. Now the point you have to understand is, okay, the chart below shown the data of the number of cars bought by millennials and generation X people in a country from the year 2010 to 2020, as well as the yearly fuel consumption of the country in million liters. Okay, now if you observe, the scale is on both left and right side, right? Left side is fuel consumption. What it is? Fuel consumption. Okay, and right side is number of cars sold. Number of cars sold. If you observe, he specified that numbers are in thousands. Means this is not 10, this is 10,000. This is not 20, this is 20,000, and so on. Okay, good. Now let us see the questions one by one. Okay, right, good. So blue, orange, and what do we say? Fuel consumption. Okay, so he has not specified that what is blue, what is orange. Okay, so millennials is nothing but orange. Millennials is nothing but blue, and the green is generation X is nothing but orange. Okay, now let me confirm one more time. Okay, I will confirm you so that we can solve it with the peace of mind. Yeah, Gen X is blue. No, so reverse. Okay, Gen X is blue and millennials is orange. Okay, right, good. Now So the line is already fuel consumption. Here I have specified. Okay. So blue, orange, what we have to understand. Right, now see the questions one by one. Okay, good. Considering the data presented in the chart, which of the following options is true? The point we have to know is blue means nothing but Gen X people, right? Okay. So Gen X people and millennials, these two are number of cars bought, not sold, number of cars bought. So number of cars bought was given on the right side. Okay, and the number of fuel consumption in million liters was given on the left side. Okay, good. So actually the point you have to notice is, it is 10,000 this line, this is 20,000, 30,000, 40,000, right? Now the point you have to observe is 10, this is also 10, that is million liters, this is thousands. This line is 20, this line is 20, right? That means that whether you observe from the left side or right side, you will get the same values, okay? No problem. That's why I can observe from any direction. Okay, so A said that the decrease in the number of Gen X car buyers from 2015 to 20, the decrease in the number of Gen X means blue, 15 to 20, here to here, decrease. So this is and this is, okay, it is 30, it is 40 and this is 35, okay, 40 and 35. 1 second, I'll give the exact values to you. Okay, I'll write the values on the graph so that we will get full clarity about it. Yeah, I'll write the values directly here. Okay, so this is 40 and this is 30 and this is 25. Okay, forget about it. Okay, so if you know this means automatically you can find it. And the next one, this is 20 and this is 45. Okay, and this value is 60. Okay, coming to fuel consumption, this dot represents 50, this dot represents 60 and this dot represents 80. Okay, those are the values so that we can solve the problem in a easy manner and clear cut manner. Okay, right, say that. Good. So the decrease in the number of Gen X cars means blue cars from 2015 to 20. So 15 to 20 blue color, 30 to 25 means 5. Okay, or 5,000 is more than the increase in the millennial cars buyers from 2010 to 15. 10 to 15. So orange, 20 to 45 means it is changes 25. What he said, the first one is more, but unfortunately that is wrong. So A is not the correct one. He is asking about the true statement, right? So first one is not the correct one. Let's go to the second one. The percentage increase. Earlier it is increase and decrease the numbers. This time the percentage increase and the percentage decrease, etc. Percentage point of view. Okay, the percentage increase in the fuel consumption from 2010 to 15. Fuel consumption means this is line 50 and this is 60. 50 to 60 means increment percentage means 10 out of 50 into 100. So it will be 20%. How much it is? 20%. Okay, 2010 to 50 means 20% is more than percentage increase in the fuel consumption from 15 to 20. 15 to 20. Fuel consumption percentage. It is 60 and that is 80. Increment is 20. 20 out of 60, okay, into 100 means 1/3. 1/3 means 33.33%. But if you observe, he said this is more, first one is, but that is not true. So B is also not the answer. Next, see, the increase in the number of millennial cars, this time not percentage, just direct increase in the number of millennial cars, car buyers from 2015 to 20. Okay, 15 to 20, 45 to 60. So how much it is? 15 is less than the decrease in the Gen X cars from 2010 to 15. Okay, 10 to 15, what we say Gen X. Gen X means blue. 40 to 30, how much it is? 10. He said that the first one is less, but that is not meaningful. So this is not. So answer is D. Okay. Now let us see, is this D or not? Okay, the increase in the number of millennial cars buyers from 2010 to 15. Millennial means orange, 2045 means 25, is more than the decrease in the number of Gen X cars, Gen X from 2010 to 15. Okay, Gen means 40 to 30, blue, right? So 10. So the first one is more, absolutely correct. So answer is D is the answer. Okay, here if you can retrieve the values from the graph, that is enough. Okay, let's see the question next one. Okay, The decimal number system uses the characters alias digits we will call in general, right? Okay, but sometimes we can call it as even characters, but exactly word is digits. Okay, 0, 1, 2 and so on 8, 9. And the octal system uses the characters or digits from, okay, 0 to 7. Yes, we know it very well, right? Okay. For example, the decimal number 12 is equals to 12 we can write. This is in the tens place, right? So we will write 1 into 10 plus this is in the units place, right? 2 into 10 power 0, that is nothing but 1, right or wrong? Okay. And the number 14 can be expressed as, this is in the units place. Okay, this system is on octal. This is on the decimal, this is on the octal. Octal means this is 8 power 0, that is units place. This is 8 power 1, right? So 8 into 1 plus 1 into 4, that is what he specified in the octal system. Okay, hope we understand. Now he is asking the decimal number 108 in the octal system is. So 108 is in the decimal. He is asking in terms of octal. Okay, this we can work out in two different ways. The simplest way I am going with. So 108, you want to go with the octal, means you have to go with the 8. 8 ones are 8, 28 means 8 threes, remainder is 4. Again, 8 ones are 8, the remainder is 5. Okay, now 154, right? So which option is the answer? D is the answer. One of the easiest question that he has given in this examination. Okay, right. So for non-zero real values x, y and real parameters a greater than 1. Okay, x is to y is equal to a square plus 1 is to, sorry, this is a plus 1, not a square. A plus 1 is to a minus 1. Then the ratio of x square minus y square is to x square plus y square is. Right, if you want to solve it, a is greater than 1, right? So you can do in two ways. Take a is equal to 2. Then automatically x is to y becomes 2 plus 1, 3, 2 minus 1, 1. Okay. Now x square minus y square, x square is 3 square, that is 9, minus y square, that is 1 is 2. Okay, x square 9 plus y square is 1. So 9 plus 1. So it is 8 is to 10. So is equal to 4 is to 5. Which option satisfies that we have to observe. Okay, if you take this, a is 2. Okay, but I want 4, right? So this is not. 2a means 4. Okay, is to 2 square plus 1 is 5, satisfied. So if any other also satisfied, I am unable to answer, right? That's why I have to wait. Okay, so 2a means 4. A square minus 1 means 2 square minus 1 is 3, not satisfied, leave it. So a means 2 only, right? 2 is 2 means not possible, leave it. So happily I got the answer as B. This is one way to solve the problem. Or else, suppose if you know the fundamental points like, okay, fundamental points like, so observe p plus q whole square plus p minus q whole square. Its value is 2 times of p square plus q square. Similarly, p plus q whole square minus p minus q whole square is equals to 4pq. Is equals to 4pq, right? Okay, if you know these 2 points, this we can work out in a easiest manner. X is to y is a plus 1 is to a minus 1, right? X square minus y square. X square means a plus 1 whole square minus a minus 1 whole square is to x square plus y square means a plus 1 whole square plus a minus 1 whole square. Observe that p plus q whole square minus p minus q whole square means 4pq. That is 4 into a into 1 is to a plus b whole square plus a minus b whole square, 2 times of p square plus q square. That is 2 times of a square plus 1 square. 2 ones, 2 twos. So overall 2 into a into 1 means 2a is to, okay, a square plus 1. So exactly you got the answer as B. This is the way that we have to solve it. Right, just a minute. Right. Observe that this is the question. In the following figure, CD is 5. Okay, CD is 5. BE is 10. BE is 10. That means this total is 10. Keep it in your brain. AE 12. AE is 12. Okay. Angle DAB is equal to angle DCB. DAB, this is equals to DCB. This is. Okay, this will happen in rhombus as well as kite. Okay. Angle DAE is equals to how much? 90 degrees. And angle DBC is also equal to 90 degrees. Okay. So points AFCD create a rhombus. Okay, fine. So, okay, fine. What he is asking is, what is the value of BE he is asking? No. I'll give you what is the question he want to ask. Yeah, length of BF we want. Okay. So then length of BF is equal to how much? Means this length he is asking. Okay, very simple question if you observe. So very simple question if you observe. Since it is a rhombus, if it is 5, this is also 5. Okay. Only focus on what I said. Just focus this triangle. Okay. Is it a right angle triangle or not? This angle is 90. So it's a right angle triangle. This is 5, this is 12. We know that 5, 12, 13 is a right angle triangle, right? So that means that DE length is 13. I'm writing here. DE is 13. Okay. So if it is 13, DE is 13, and we know that BF is 10, means this is 3. As we know that in rhombus diagonals bisect each other. So that's why this is 3, means this is also 3. I'm changing the color and I'm showing you. Okay, if it is 3, okay, then this is also 3. He's asking about its length BF. Okay, is how much? 3. So that is the answer. Okay. And even if you want AB also we can calculate. We know that 3, 4, 5 is a right angle triangle. This is 3, this is 5, means this is 4. So this is also 4. Okay. Right. Let's see the last question, my dear boys and girls. Just a second. I'm importing. Right. So this is a funny question actually, if you observe. Okay, and of course it we need to draw some more drawings also here. Okay, that we will draw now. Okay, good. The diagram that we have to draw here is actually it's a gears based diagram. Funny one. So the diagram is, suppose here it is a rigid end. We have some this type of thing, and that is attached to a gear. Okay, don't ask me to draw exactly gear diagram. Okay. Means this went to this place. Okay. Okay, this is a gear. Don't ask me exactly diagram. Okay, good. Now this one is connected to some other gear like this. Okay, this is another gear. Okay, it has some like this. Okay, these two are connected here, and this is connected to the next one like this. And so on. So these are the teeth of the gear. Okay, fine. Now like this, there is another one called here. The interlockings are like this. Okay, good. This is the system that he has given to us in the diagram. Okay, now if you observe, This is the assembly. The assembly shown below has 3 teethed circular object called pinions, these 3, okay, and 2 teethed flat objects known as racks, okay. These 3 are pinions and these are racks. This is one rack and this is another rack, okay. So pinions can only rotate clockwise or anti-clockwise, staying at its own center, okay. Means taking this as the center, it will rotate either clockwise or anti-clockwise. Same to same, saying it as a rotates clockwise or anti-clockwise. Okay, taking it as the center, clockwise or anti-clockwise, it will rotate. And next one, racks can translate towards the left or right directions only. These are the racks, right? It will not rotate. Okay, it will go either left and right only. Okay, based on the gear movements, etc. Okay, next one, the object A. This is object A. This is object A, and this is object B. Okay. The object A translating towards the right, that is right arrow, means this is the direction. The correct statement among the following is, okay, object B translates towards right, object, yeah, these are known as PQR, okay. This is object P, okay, and this is object Q, and this is object R. Okay, those are PQR. Okay, object R rotates in the anti-clockwise, object Q rotates in the clockwise, object B translates towards the left direction. Okay, this is what the question that we have. So if you observe 2 gates, always, if it is running like this, okay, then automatically what happens if it is running like this? The other moves in the opposite direction. Is it correct or wrong? Okay, so what we have to observe is, okay, the evolution, if you observe where we will get cane juice, okay, those 2 rotates like this. But if you observe, you feel that both looks the same direction. Okay, but one is clockwise, so this hand is clockwise direction, this hand is anti-clockwise. Both crush like this, right or wrong? So 2 gates always run like this, okay, but one is clockwise, the other is anti-clockwise. Opposite directions always. Okay, now if you observe the question, he specified that object A is moving towards the right. That's what he specified. If it is running right, automatically it runs to this is direction, right? Automatically it runs like this. Is it correct or wrong? So this will be pulled like this and it will move like this. So P will be moved in clockwise. Okay, clockwise. Now if you observe P and Q are 2 gates, right? Like this. Okay, so one is clockwise means the other will be in anti-clockwise. So if P is in clockwise, Q is in anti-clockwise. Okay. Now these 2 if you observe, again 2 gates are running, right? If one is clockwise, the other will be anti-clockwise, right or wrong? So this is anti-clockwise, means this will be in clockwise. Clockwise means it is running like this. Okay, is it right? So it is running, so it is, it is running in clockwise direction as it is moving right side. It runs right, so automatically it is running right, means it is running like this. Okay, if it is running like this, automatically it runs like this. Okay, if it runs like this, automatically what happens, which direction we can say this is clockwise, right? Okay, it runs like this, means automatically it goes to the left direction. So answer is D. Okay, so object R anti-clockwise is wrong one. Object Q clockwise, wrong one. Okay, so this is the one. If it is going right, automatically it turns like this, it turns like this. If it is not turning like this, it turns like this. Okay, if it is turning like this, automatically this will run this direction. So answer will be the object B translates towards the left direction. Okay, my dear personals, hope you understand how it runs. Okay. So this is the answers for my part of aptitude. Hope you all understand. I think I did my level best. Thank you. So this is very much helpful to you. So thanks the OM organization. So myself Amarnath Dhimani signing off. Jai Hind.
All right, guys, we'll continue this session. Now we shall look at the analog circuits questions from today's electrical paper. So this is what a 2-mark question, which is related to diodes. So in the circuit shown, the current I1 through diode D1. So this is what the diode D1. Okay, and you have to find the current through D1 in milliamps. Okay, so in fact there are 2 diodes in this circuit, and there is no mention of the cut-in voltage or the on voltage. So we have to assume that both the diodes are ideal. Okay, so V on is what, 0. So it's all about deciding the state of each diode, whether each diode is on or off. Before we do any analysis, it may be a good idea to replace this part of the network with its Thevenin equivalent. Okay, only this vertical branch, which comprises of 10 volts, 1K and also 1K. Okay, so with respect to this thing, we are replacing this with its Thevenin equivalent, which will be 5 volts in series with 0.5 kilo ohms. Okay, 1K parallel 1K is what? 0.5 kilo ohms. So let me draw the modified circuit. So we have the Thevenin voltage of this network, that is 5 volts, followed by the Thevenin resistance of the same network, which is 0.5 kilo ohms, and then we have the rest of the circuit as it is, which is D2. So this is what D2 in series with 1K, and then you have another 1 kilo ohm resistor, and this is what D1, and you should find the current through D1. Yes. Now if you look at D2, please observe D2. So for D2, this is what P side, this is what N side. P side connected to what, 5, and N side is what, connected to 3 on one side and 0 on the other side. So P side is connected to 5, N side is connected to what, 3 or 0, and 5 is what, greater than both 3 as well as 0. So without doing any kind of checking or testing, directly we can say that D2 is what, definitely on. This is the point. So in this circuit, D2 for sure it is going to be on. Okay. So once you know that D2 is on, you can replace D2 with a short circuit, since the cut-in voltage is what, 0. Now I'll just remove this diode D2. So in place of D2, let's connect this short circuit and let the current in this short circuit be some I2. Now you can, now the circuit becomes what, a single diode circuit. After replacing D2 with a short circuit, we are left only with D1. So now the circuit is like a single diode circuit. In a single diode circuit, we can simply find VOC across that single diode and compare it with V on and decide whether that single diode is on or off. So let us just remove D1 and find the open circuit voltage. Well, I am guessing that D1 is going to be on. Okay, and we will just remove D1. So after removing D1, you sort of get this open circuit. Call this open circuit voltage as what, VOC. Now this 0.5K, 1K and also this 1K, all three will be in series across 5 volts. So from voltage division, the voltage at this point would be 5 into 1 upon 1 plus 1 plus 0.5, which is 2.5 volts. So that means VOC will be what, 3 minus 2.5, which is 0.5 volts, and this is what, greater than 0. Yes, or greater than V on. That means the diode D1 is going to be on. Okay. So now that you know D1 is going to be on, now we can replace D1 with short circuit. So I'll just clear this off. So just now we found that D1 is also going to be on. So replace D1 with a short circuit like this, and let this current be I1. Now you have to do the analysis and find the value of I1. Pretty simple. Now the voltage at this point would be 3 volts because this is directly short to what, 3 volts, and the voltage at this point is what, 5 volts, and the current in this branch is what, I2. So I2 can be easily found using Ohm's law. 5 minus 3, which is 2 volts, upon 1.5, sorry, 1.5 kilo ohms. 2 by 1.5 kilo ohms is what, I think 4 by 3 milliamps. That is what the value of I2. Even this current is what, straightforward, it is 3 milliamps. Now all we can do is what, to write KCL at this point. I1 is entering, I2 is entering, 3 milliamps is what, leaving. So writing KCL over there will give us the value of I1, and that would be 3 milliamps minus 4 by 3 milliamps. Okay, so LCM is what, 3 times 3 is 9, 9 minus 4 is 5. So I am getting I1 as what, 5 by 3 milliamps, which is 1.666 or 1.67 milliamps. And as you can see, I1, it is indeed positive. It should be positive because after all diode D1 is on. So this is what the question on diode circuit. There is one more question which we shall discuss. So this is yet another 2 mark question. So what circuit is this? Is it not the difference amplifier? So if you have studied analog circuits, you must be knowing that this circuit, it is what, difference amplifier. And what should this difference amplifier do? There will be 2 inputs, as you can see here, V in 1 and V in 2. And this amplifier is supposed to compute the difference and then amplify the difference. Okay. So this is similar to what, differential amplifier. Every differential amplifier is characterized by a CMRR. Even for this difference amplifier, there will be some CMRR, and that is what you should find. So you have to find CMRR in decibels. Okay. So firstly, what is CMRR? It is the magnitude of the differential gain to the common mode gain. So in order to find CMRR, you should find AD and you should also find ACM. Okay. So this is not an ideal difference amplifier. Ideally, that CMRR must be infinite and so on. Okay. So if you call this R2, if you call this R1, if you call this R4, if you call this R3, then for this overall circuit, which is what, the difference amplifier to be ideal, R4 by R3 must be equal to what, R2 by R1. And for the given values, R4 by R3 is clearly not equal to R2 by R1. So this is what, a non-ideal difference amplifier. So the op amp is what, ideal. So don't confuse between the op amp and the overall circuit. So using an ideal op amp, we are trying to build or make a difference amplifier, and that difference amplifier is not ideal. Okay, it is what, non-ideal. So the CMRR would not be infinite, it will be some finite value, and that is what we need to find. Anyway, let's do the analysis. So ideal op amp, input currents are 0. So what is the voltage at this point? It is V in 2 times 101.5 divided by 9.5 plus 101.5. Simple voltage division. So that is what, V plus. Okay. So 101.5 plus 9.5 is what, I think 110. So it is what, V in 2 times 101.5 divided by 110. divided by 110. Okay, so that is V plus, and then at the top this 101 kilo ohms and 10.5 kilo ohms will definitely be in series. So you can write down the voltage at this point in terms of V in 1 and V naught. Just do it. So V minus, which is what the voltage at this point, will be what? V naught times this. So V naught times 10.5 plus V in 1 times 101 upon the sum of the two resistors which are in series, 101 plus 10.5. So 101 plus 10.5. So numbers are not that convenient. Okay, they should have given easier numbers to deal with. Okay. So this again 101 plus 10.5 is what? 111.5. Okay. Anyway, because the op amp is what ideal and it is connected to negative feedback, we can use the concept of virtual short. So what is our virtual short? V plus equal to what? V minus. So in place of V plus, you write V into times 101.5 divided by 110 is equal to V minus, which is this thing, V naught times, sorry, V naught times 10.5, V naught times 10.5 plus V in 1 times 101, V in 1 times 101 divided by this, which is 111, right? 111.5, 111.5. So from this equation, we can find V naught in terms of V in 1 and V in 2. Okay. So what is it? V naught is equal to what? V in 2 times 101.5 into 111.5 divided by 110 minus V in 1 times minus V in 1 times am I missing anything here? Okay, 101.5 into 111.5 by 110, this is correct. So 111.5 has gone to the other side, and then V in this thing goes to the other side, minus V in 1 times 101 by 10.5. This should be correct. I hope this is correct. Okay. So right now we have what? V naught in terms of V in 2 and V in 1. But to find CMRR, you need to find AD and ACM. So this output expression should be modified in such a way that V naught will be represented in terms of VD and VCM. Okay. So here you need to make a small modification. In place of V in 2, you must write VCM plus VD by 2, and in place of V in 1, you must write VCM minus VD by 2. Then you will get V naught in terms of VCM and VD, and from there you can find the values of AD and ACM. Okay. So calculation is getting a bit clumsy as well as lengthy. So I'll just try to do it. So 101.5 into 111.5 divided by 110. So V naught equal to what? The first term comes out as 102.0 88, okay, 102.88 V in 2, and the second term is what, 101 by 10.5, which is 9.62 minus 9.62 V in 1. Now, as I said, in place of V in 2, you must write this. In place of V in 1, you should write this. So, V naught equal to what? 102.88 times V in 2 minus 9.62 times V in 1. 9.62 times V in 1. Now, in place of V in 2, let us write VCM plus VD by 2, and in place of V in 1, let us write VCM minus VD by 2. Let's see what we are going to get. Okay. So, V naught equal to what? 102.88 times VCM plus VD by 2 minus 9.62 times VCM minus VD by 2. 102.88 minus 9.62, which is 93.26 times VCM, okay. And then also combine the two VD terms, what do you get? 102.88 plus 9.62 divided by 2, 56.25. So, this is the output in the standard form. Now, you have to compare this with the standard form of the output, which is the common mode gain times the common mode input plus the differential gain times the differential input. So, now by comparison, we can see AD is what, 56.25, whereas the common mode gain, it is what, 93.26. I hope these values are correct, and if it is not so, please excuse me, okay. So, from here we can find CMRR, which is, in fact, we have been asked to find CMRR in decibel scale, which is 20 log AD by ACM to the base 10, okay. So, let us just find the value of this. So, log of 56.25 divided by 93.26. So, the value of the logarithm is what, minus 0.219, and then multiply it with 20 minus 4.4 dB. Minus 4.4 dB. So, there is every chance that the answer might be incorrect, because somewhere during the analysis I would have made a mistake. Yes, because numbers are really terrible, okay. Anyway, I'll just move on. There is one more question. is again a 2-mark question, and there is a BJT circuit. In fact, there is what an NPN transistor. This is what an NPN transistor. A BJT biasing circuit is shown below, and for the BJT, the base emitter voltage is what the usual 0.7 volts, and its common emitter current gain beta is what 100. You have to find the values of VCE and IC. So there is a problem on DC analysis. So you just have to do DC analysis, okay. So because beta is what 100, the base current is not 0. Had the base current been 0, then you can say these two are in series, then we can directly apply voltage division, etc. But in case beta is finite and not large, you cannot apply that simple voltage division. So the best way, I think at the bottom we have ground. I guess the ground is what missing, okay. So the best way forward is to replace this vertical network with its Thevenin equivalent. So what is the Thevenin equivalent of this yellow color part of the circuit? VTH will be what? 12 into 50 by 100 plus 50. 12 into 50 by 150 is what? 12 by 3, which is 4 volts. And RTH will be what? The parallel combination of 50K and 100K. Yes. So VTH is what? 3 volts, and RTH is what? 50K parallel 100K. 50 into 100 divided by 150. 50 into 100 divided by 150 is what? 100 by 3 kilo ohms. So these are the values of VTH and RTH of this network. So let us replace only this part of the circuit with its Thevenin equivalent, okay. So VTH in series with RTH, and then you have the rest of the circuit as it is. So this is what the transistor, and this is what RE, which is 1 kilo ohm, and then at the collector we have RC, which is 2 kilo ohms, and the supply voltage is what? 12 volts. Now we just have to apply KVL around this loop. Well, before that we have to write down the base emitter voltage drop, which is 0.7 volts, and we know this current is what? The base current, and this current is what? The emitter current. So this drop is what? IB times RTH, and this drop is what? IE times RE. Now if you write KVL around this loop, yes, let us write KVL around this loop. VTH is equal to what? IB times RTH plus 0.7 plus IE times RE. Now let's assume the transistor to be operating in active. Let's assume the transistor to be operating in active, okay. In the end we'll check the condition for active. So here assume the transistor to be in active. So once you assume transistor to be in active, IE can be written as what? 1 plus beta times IB. IE can be written as what? 1 plus beta times IB. VTH is what? I think we found VTH as what? 3 volts, correct? VTH is what? 3 volts or 4 volts? 12 into 50 by 150. 12 by 3 is what? 4. So here I made a mistake. This is not 3, this is 4, okay. So 4 is equal to what? IB times RTH plus 0.7. IE is what? 101 times IB, 101 times IB, and then RE. So from here we can find the value of the base current. So 4 minus 0.7 is what? 3.3 volts upon RTH plus 101 times RE. 3.3 volts. What is RTH? 100 parallel 50, which is 100 by 3 kilo ohms. 100 by 3 kilo ohms plus 101 times RE. RE is what? 1 kilo ohm. So it is what? 101 kilo ohms. Let me find the value of IB, that is the base current. So 3.3 divided by so the base current comes out as what? 0.0246 milliamps. That is what the base current. So once you find the base current, you can find the collector current. So because IC is what? Beta IB, and beta is what? 100. So it is what? 100 times IB. So if you multiply this with 100, what do you get? 2.46 milliamps. That is what the value of IC. Okay. So once you get IC, remember this current is what? IC. Then what is the drop across 2 kilo ohms? It is IC times RC, sorry, into 100, wait, into 2. So this drop, it is approximately 4.92 volts. Okay. So 12 minus 4.92. So the voltage at the collector terminal is what? 7.08 volts. Let us also find this drop, the drop across RE, which is IE times RE. So 0.02456 into 101. Yes. Into, okay. So this drop, it is what? 2.48 volts, which means the voltage at the emitter is what? 2.48 volts. If you know the voltage at the emitter, just add 0.7 to it, you will get the voltage at the base. So 2.48 plus 0.7. So the voltage at the base turns out to be 3.18. Remember, we got all these values by assuming transistor to be inactive, and for active, your VC should be greater than VB. What is VC? 7.08. Base is what? 3.18. Clearly, this condition is what? Satisfied. Our assumption is what? Correct. And the other thing you have to find is what? The value of VCE. So what is VCE? It is 7.08 minus 2.48, which is 4.6. So IC is what? 2.46, and VCE is what? 4.6. So these are the values of IC and VCE. And which option is it? It is option D. VCE is what? 4.6. IC is what? 2.46 milliamps. So that's it. These are all the questions from analog circuits we were able to gather. I'll hand it over to Shankar sir, who will start with power electronics. Thank you. Sir, apandi.
Now we will look into power electronics questions of electrical paper. Now the first question from power electronics. In the following devices having similar power ratings, then which one of them is fastest device? Now by seeing the options, the highest switching frequency capability of any power semiconductor device is power MOSFET. It's a straight question. So answer for the question is power MOSFET. Now let us move to the next question. Next, another interesting question. A single phase full bridge voltage source inverter feeds a purely inductive load. The inverter output is a square wave in 180-degree conduction mode. The fundamental frequency of the output is 50 Hertz. Therefore, immediately I can calculate here when F0 is equal to 50 Hertz, it will give you one cycle time is equal to 1 by 50, that is 20 millisecond. If the input voltage of the inverter is 100 volt, let us note down this data. Source voltage to the inverter circuit is 100 volt and the load side inductance is 20 millihenry. Now we need to calculate the peak to peak load current in ampere. Now here for voltage source inverter, when the load is pure inductance, the output current waveform is a triangular waveform whose slope is, so this is a I0 waveform. The slope of this inductor current or output current will be source voltage divided by load inductance. Now here the question is find peak to peak load current. So first let us calculate what could be height of this. Let us say this is a IOP, peak value of the output current, and if you take x-axis in millisecond, one cycle time will be 20 millisecond. That means up to here it is a 10 millisecond and up to here it will be 20 millisecond. Now say for example, let us give this triangle name ABC. So in triangle ABC, by applying the slope concept, VDC by L is equal to, in a triangle ABC the slope is VDC by L is equal to opposite side BC divided by adjacent side AC. So here BC is equal to VDC by L, where VDC is 100 divided by inductance is given 20 millihenry multiplied with AC, that AC is 10 millisecond. So this value is equal to milli cancel, this is a 5, this is a I am sorry, this will be 5 millisecond, I am sorry. AC will be 5 millisecond, so that this will be 25 ampere. Now BC is a peak current, peak value of the output current, and the peak to peak current means peak to peak current is equal to 2 into IO peak, and this will give you 50 ampere. So for this question the correct answer can be 50 ampere. Now let us move to the next problem. Now this question is based on DC to DC converters. Let us read the question. In the DC to DC converter shown below, II is a continuous, that means source current is continuous here. Let me expand this diagram. Okay. Source current is continuous and the switching frequency is 500 hertz. And the output voltage is constant and ripple free, that is the V0 is given constant. Find the peak value of the input current. Okay. So the given circuit here is boost converter. So the given circuit is boost converter. So what we need to find out? Find the peak value of input current. That means peak value of input current. You can also say that peak value of inductor current. By looking into the formula for peak value of the inductor current, average value of the inductor current plus half of the peak to peak ripple current. It is mentioned that inductor current or input current is a continuous, hence we can take that like that. Now we need to calculate one by one. So what is the first one? IL is equal to IL is equal to I0 divided by 1 minus D. In boost converter, IL is equal to I0 divided by 1 minus D. Now here it is mentioned that output voltage to input voltage ratio will be 1 by 1 minus D. Output voltage is given 40 volt, input voltage is given 20 volt, hence 40 divided by 20 is equal to 1 by 1 minus D, hence from this we will get duty cycle ratio is 1 by 2 or 50% duty cycle ratio. Then what is I0? That is V0 divided by R divided by 1 minus D, where V0 is given as 40 volt, load resistance is 10 ohm, hence I0 can be 4 ampere divided by 1 minus 1 by 2. Therefore, it will give you 8 ampere. So, average value of inductor current, which is also same as average value of input current, that is 8 ampere. Now, let us try to find out what is the peak to peak ripple in inductor current. The formula for this is VDC divided by L multiplied with D into T, where VDC is a 20 volt, that is a source voltage, divided by inductance 2 millihenry, 2 into 10 power minus 3. Duty cycle ratio is given 1 by 2. Cycle time will be 1 by switching frequency, that is 1 by 500. Therefore, so this value I calculated and this is a 10 ampere. Then finally, peak value of input current, which is nothing but peak value of inductor current. This is average value of inductor current plus half of peak to peak ripple current, where we got average value of inductor current is 8 plus 10 by 2. So this will be 13 ampere. Peak value of inductor current or peak value of the input current will be 13 ampere. Even if you look into the waveform, this inductor current waveform will be something like this, whose average current will be horizontal line. So this is average current, and inductor current peak value can be expressed as IL plus half of the peak to peak ripple current. So answer is 13 ampere. So let us move to the next problem. Now this question is framed very interestingly. Strictly speaking, electric drives are not in the syllabus. However, we cannot claim that it is out of syllabus question, because it is clearly mentioned that a single phase full converter circuit is driving the DC motor. So it is a mixture of power electronics as well as electrical machines. It is an application oriented question. So straight away we cannot claim it is an out of syllabus question. Now let us try to solve this problem. A single phase fully controlled thyristor converter bridge is used for regenerative braking of a separately excited DC motor with the following specifications: rated armature voltage of 210 volt, rated armature current of 10 ampere, and rated speed is 1200 rpm, and armature resistance is 1 ohm. So what we can do, at rated conditions, if you find out back EMF of the motor, so let us call it EB1, terminal voltage, that is 210 volt, minus armature voltage drop. Okay, so that means 10 ampere multiplied with 1, right? 10 ampere multiplied with the 1 ohm. Therefore, this value is 200 volt. So here rated condition means at a speed of 1200 rpm. So that is what the meaning is. Now what is the question it is asking? Input to the converter bridge is 240 volt 50 hertz, that is the AC side of the bridge circuit. We will use it later. Now it is required that the armature of the DC motor is fed from fully controlled bridge and field current is kept constant. Okay, next, the motor is running at a 600 rpm and armature terminals of the motor suitably reversed for regenerative braking. So at 600 rpm, speed, let us try to find what is the back EMF, and let us call it EB2. So this will be 210 volt. Okay, let us find it like this. EB2 divided by EB1 is equal to N2 divided by N1. Therefore, EB2 is equal to 200 multiplied with 600 divided by 1200, as the speed is reduced by half and the field current is constant. So back EMF will also reduce by half. So this will be 100 volt. Now it is mentioned that under this condition regenerative braking is required. Okay, so under this condition regenerative braking is required. For regenerative braking, what I can write down, for regenerative braking you have to reverse the back EMF polarity. So I can take minus 100 volt. Under this condition, what could be the terminal voltage of the DC motor? That will be minus 100 volt plus armature drop. So for the armature drop, it is mentioned that armature current of the motor is maintained at rated value. Therefore, there is no change in the armature current. Hence, I can take simply 10 ampere into 1. So that is a drop. Okay. Therefore, this value is minus 90 volt. So what is the point to understand here in a bigger picture? Under rated speed, the motor back EMF is 200 volt. When the speed is 600 rpm, means it reduced by half, the back EMF should be 100 volt. But under this condition, it is mentioned that regenerative braking has to initiate. Therefore, the terminal voltage should be negative, right? Now, this motor is driving from single phase full converter bridge. What we can do, we have to equate this minus 90 volt with the output voltage of the single phase full converter bridge. Therefore, what I can write down, 2 Vm by pi cos alpha should be equated with minus 90. So, with this, cos alpha is equal to minus 90 into pi divided by 2 into Vm. What is Vm here? Peak value of AC source voltage. AC source voltage RMS value is given 240, hence 240 multiplied with root 2. This value I calculated, it is minus 0.416. From this, we can calculate alpha value 114.6 degree. So, this is what we need. What is the triggering angle of the converter in degree? That is 114.6 degree. This firing angle is greater than 90 degree, so that the circuit full converter bridge is operating under inverter operation. Sorry, this is a 90 degree. So, this is a solution for this problem. Let us move to the next question. Now, here also this particular question, according to the syllabus, AC voltage regulators are not mentioned. However, this question also we cannot claim it as an out of syllabus, because there is a one word in the syllabus, it is mentioned that line commutated thyristor based converters. So, AC voltage regulator also comes under line commutated category. That is why generally I used to discuss these concepts in the class. It is a very easy question. A single phase time based voltage controller feeds a series RL load. The input supply is 230 volt 50 hertz. The value of R and L are 10 ohm and 18.37 ohm. The minimum range of triggering angle to obtain controllable output voltage. So, here the minimum value of so for V0 to control, firing angle should be greater than or equal to phi, where phi is load power factor angle, where phi is equal to load power factor angle. So, here that is tan inverse XL divided by R. So, that is tan inverse XL means 2 pi f into L divided by R. Tan inverse 2 pi, frequency is given as 50 hertz, inductance value is given as 18.37 millihenry divided by load resistance. That load resistance is somewhere it's 10 ohm, and this value is 30 degree. This value is 30 degree. Therefore, answer will be 30 degree. Let us move to the next question. And this question is from commutation circuits. Now, let us look into what is the question here. A load connected thyristorized step down chopper is shown in the figure. Neglect on state voltage drop across the power device. Assume the capacitor is initially charged with the polarity of 50 volt as shown in the figure. So, try to follow carefully here, that 50 volt is same as the source voltage. It is nothing but initial voltage across the capacitor Vc naught is equal to 50 volt, which is same as source voltage. Source voltage is VDC or 50 volt is given in the problem. Now assume the load current is constant, that is at 10 ampere. Initially main thyristor is turned on and auxiliary thyristor is turned off. What is the time for main thyristor to turn off in millisecond when auxiliary thyristor is thyristorized? That means, say for example, if auxiliary thyristor is turned on, now say for example here at this up to certain instant capacitor voltage is minus 50 volt, or let us say minus VDC. VDC is a 50 volt. Now at this moment or at this instant, let us say T naught, auxiliary thyristor is triggered. That is what mentioned. Auxiliary thyristor is triggered. Whenever auxiliary thyristor is triggered, there will be a circuit path like this. Load current, constant load current of 10 ampere will flow through auxiliary thyristor, and then what happened, whatever capacitor voltage is there, this capacitor voltage will directly applied across main thyristor. Then what happens, capacitor voltage will change from minus VDC to plus VDC as a constant current is flowing through capacitor. We discussed it several times in the class. The slope of the capacitor voltage will be current flowing through the capacitor divided by capacitance value. Okay, so this will be, let us say, I naught divided by C. Therefore, what is this particular time interval is referred as circuit turn off time for main thyristor. Okay, so this is a capacitor voltage waveform. How to find circuit turn off time for the main thyristor? If you apply the slope equation, that is I naught by C is equal to, opposite side I can write VDC divided by circuit turn off time TC. Therefore, TC is equal to C multiplied with VDC divided by I naught. And what is the capacitance value given? That is a 10 microfarad, 10 into 10 power minus 6 into source voltage is 50 volt divided by load current 10 ampere. So this will give you 50 microsecond, but the question is asking in millisecond. We want the answer to be in the millisecond. That is, it is an equivalent of 0.05 millisecond. Therefore, the correct answer could be 0.05. So these are all the power electronics questions that I collected from my source. So with this, I can conclude power electronics questions. Now let us move into control systems. Now the first question in the control systems, some block diagram is given, very simple block diagram. We need to find what is the transfer function of the control system. So we can simply apply by SFG concept. Therefore, forward paths, if you write down, forward paths, M1 is equal to, in this case, G of S, with the, here notice carefully minus symbol is there, hence it will be minus G of S, and delta 1 is equal to 1 minus 0. Next, let us identify what are the individual loops. L11 is equal to this loop, this is a one loop, hence it will be G of S, and second individual loop is this one. Okay, so I can say one is like this. So there are two minus symbols, hence minus into minus will give you plus G of S. Therefore, delta is equal to 1 minus g of s plus g of s. Okay, so this is equal to 1 minus 2 times of g of s. So final transfer function will be c of s divided by r of s is equal to m1 delta 1 divided by delta. Therefore, minus g of s divided by 1 minus 2 into g of s. So, option B will be the correct answer for this question. Now, here for the control system shown in the figure, the overall transfer function can be approximated as. Now, this particular question is based on dominant pole concept. So, what is that? By observing the poles of the given system, one pole is located at -1, another pole is located at -20. So, if you take here, this pole is located at x units and this pole is located at greater than 5x units. That means dominance condition is satisfied. That means the pole is located at a -20 can be neglected. Therefore, by taking DC gain of the overall system will be 40 divided by 20, it will give you 2. Therefore, overall transfer function C of s divided by R of s can be approximated as 2 divided by s plus 1. Okay, the pole located at more deeper into the left half of the s plane, that can be neglected. Therefore, 2 by s plus 1 will be the correct answer for this question. Now, here this is a very simple question, but some concept is there. A closed loop system is shown below. A closed loop system is shown below. The asymptotic Bode magnitude plot g of s has a constant slope of -20 dB per decade, at least till 100 radian per second, with a gain crossover frequency of 10 radian per second. So, that means if you look into the magnitude plot, you can draw magnitude plot something like this, at least up to omega is equal to 100 radian per second, up to omega is equal to 100 radian per second, the slope of this magnitude plot is given that -20 dB per decade. But it is also given here with a gain crossover frequency of 10 radian per second. What do you mean by that? The magnitude plot will cross 0 dB line at a frequency of 10 radian per second. Therefore, what we can say here, this is a type 1 system. How can I know this is a type 1 system? Because the initial slope of the system is given that -20 dB per decade. Because of that, we can conclude it is a type 1 system. Now, in case of type 1 system, I can say that the static error constant Kv is equal to the frequency where it is crossing 0 dB line. So, that will be 10. Kv is equal to 10 here. Now, what is the question? Find the steady state error of the closed loop system for unit ramp input. When a type 1 system is there, for that, by applying a unit ramp function as an input signal, the steady state error will be the steady state error with ramp function is equal to 1 by kV. Therefore, answer is 1 by 10, whose numerical value is equal to 0.1. 0.1 is the answer for this question. Now, let us move to the next question. So, in this question, this problem is based on root locus diagram and angle of departure. A closed loop control system is shown in the figure, in which g of s is given by k into s square minus 2s plus 2 divided by s square plus 2s plus 5. The root locus for the closed loop system is drawn for 0 less than k less than infinity. The angle of departure, you have to give the conclusion in between 0 degree and 360 degree of root locus drawn from the pole minus 1 plus j2. So, from the given forward transfer function, we can look into open loop pole 0 plot, open loop pole diagram, of course. Now, 0 numerator side 0, it is given that 0 is located at, let me take like this, one, this is a plus j1 minus j1, right. Next, poles are located at plus or minus j2 minus j2 minus j2, right. So, in this case, what is the question here? Find angle of departure that is drawn from the pole minus 1 plus j2. Now, say for example, root locus is departing with this angle. So, let us take this angle is theta 1, okay, theta 1, that is let us assume that a point on the root locus diagram is very close to that minus 1 plus j2 point. Therefore, we need to find angle contributed from all zeros and poles to this point. So, this angle will be, let us say, theta 2, theta 3, and this angle is theta 4. So, what you can write down here, minus theta 1 0 angle contribution plus theta 2 plus theta 3 minus theta 4 is equal to 180 degree, is equal to 180 degree. Now, here minus theta 1 plus theta 2 means I can write 90 degree plus tan inverse. So, this will be opposite side by adjacent side. So, tan inverse 2 by 1 plus 90 degree plus tan inverse theta 3. So, this angle again opposite side is 2 and adjacent side will be, this is 2 by 3 minus 90 degree is equal to 180 degree. Therefore, here minus theta 1 plus 180 degree plus tan inverse 2 plus tan inverse 2 by 3 minus 90 degree is equal to 180 degree. Therefore, here we can cancel 180 on both sides, then it will give you minus theta 1 is equal to 90 degree minus calculator 90 degree minus tan inverse 2 is 63.43 degree minus tan inverse 2 by 3 33.7 degree. So, this will give you 90 minus 63.43 minus 33.7. This is a minus 0.713 degree, or theta 1 is equal to 0.713 degree. So, this is a angle of departure. I had a doubt in this calculation. ఆన్సర్ చెప్పొద్దు. Ready? Now next question is, this question is based on the Bode plot. A stable closed loop system is shown below. The magnitude and phase values of the frequency response of G of S are shown below. The value, we need to find out the value of K1 in such a way that phase margin of the system is 50 degree. So in this case, first let us write down what is the basic definition of the phase margin. Phase margin is equal to 180 degree plus phase angle of the open loop transfer function. So what is that? Minus 90 degree plus phase angle of G of j omega at gain crossover frequency. Okay, let us keep it like this. This value is given as 50 degree. Therefore, by calculating here 90 plus angle of G of j omega GC. So phase margin will be defined at gain crossover frequency, and hence from this we can find out angle of G of j omega GC is equal to minus 40 degree. Now from the table we can take here, when the phase angle of the G of j omega is minus 40 degree, the corresponding frequency is 0.5 radian per second. That will give you that from the table you can find out gain crossover frequency is 0.5 radian per second. 0.5 radian per second. Now what we need to find out? We need to find out gain of the K1 value. But at gain crossover frequency, what is the magnitude of the forward transfer function? That is 1. So that means magnitude of K1 into G of j omega, or you can also, okay, let me write like this, divided by j omega is equal to 1. In absolute values it is 1. Now by applying this or converting into magnitude in decibel, I can write it like this: 20 log K1 plus 20 log magnitude of G of j omega GC minus, let me write down here, minus 20 log omega GC is equal to 20 log 1. So 20 log 1 right hand side will give you 0 decibel. Therefore, this will be 20 log K1 plus 20 log of magnitude of G of j omega, that is given as minus 7 dB. Therefore, I can say this is a minus 7 dB minus 20 log, we determined omega GC gain crossover frequency is 0.5 is equal to 20 log 1, that will give you 0 decibel in the right hand side. Therefore, it will give you 20 log K1, this numerical value minus 7 plus 6.02 is equal to 0. By solving this equation, you will get K is equal to 1.12. So answer for this question is 1.12. And the last question from control systems. For a second order system, C of S divided by R of S is equal to omega n square divided by S square plus 2 zeta omega n s plus omega n square shown below. Now, for the system 1, omega n is 3 radian per second and theta is equal to 60 degree. Therefore, when theta is 60 degree, what I can say that damping ratio is equal to cos 60 degree, that will give you 0.5. Next, for the system 2, damping ratio will be cos 70 degree. Cos 70 numerically is 0.34. Okay. Now, which of the following statement is true? So, it is mentioned the options are based on settling time numerical. So, as per settling time formula, if nothing is mentioned, you can consider that 2% criteria, the formula will be 4 by zeta omega n. So, for system 1, settling time, let us call it TS1, 4 divided by zeta is 0.5 multiplied with omega n is 3 radian per second. This numerical value will be 2.67 second. For system 2, settling time, you can express it as, you can take here, let us write down, this will be for 5% criterion, or you can also take 2% criterion because it is not mentioned. Any one criterion you can consider. In this case, you will get 4 divided by 0.34, and even if you take a 2% criterion also, you will get a correct conclusion. So, this will be 11.76 second. So, we can say that here TS2 is greater than TS1. Settling time for system 2 is greater than settling time for system 1. This is the answer. Now, with this power electronics and control systems, I can conclude. Now, next subject, networks. Gautam sir will continue. Thank you.
All right, guys, now we'll jump into the questions from electric circuits or network theory. And we were able to gather about 5 questions. Let us quickly go through all 5 of them. So the first question is this one. The number of junctions in the following circuit is, so some circuit is given, and in this you should identify and count all the junctions. Okay, so what is a junction? Junction is a node at which 3 or more branches are connected to each other. What is a node? Node is a point at which 2 or more elements are interconnected with each other, whereas junction is a node or a point at which at least 3 branches are connected with each other. Okay, so even in the context of railways, okay, so what is a junction? So for example, Vijayawada, it is what a big junction, because a lot of railway lines from various routes converge at Vijayawada. Okay, but not all stations are junctions. Okay, anyway. So the point is what, not every node is a junction. Yes, only a few nodes are junctions. So this node, at this node 3 branches are connected, so this is what a junction. Okay, whereas this one it is not. This one it is, and this node it is not a junction, only 2 branches are connected. So in fact this entire thing is what, one single node. At this node 5 branches are connected, so it is definitely what, a junction. Okay, so this node is also what, a junction, because 3 branches are connected. So this entire thing is also what, a node, and there is also another junction. So even this is what, a junction. There is also what, a junction. Okay, but this particular node is not a junction. So I think we have labeled or identified all the nodes, and also those nodes which happen to be junctions. Okay, so the nodes with the tick marks, they can all be counted as junctions. Okay, 1, 2, 3, 4, 5, 6. So number of junctions is what, 6. Number of junctions is what, 6. Let's move on to the next question. Just read it out for you. Power delivered by the 10-volt source. Which one? This one. So in watts in the following circuit is depends on alpha. So alpha is what, the value of this resistor that is connected in series with the 10-volt source. Or is it 100, or is it 50, or is it 0? See, first of all, how do you find the power delivered by the 10-volt source? For that you need to find this current I, and then 10 volts into I will be what, the power delivered by the 10-volt source. Okay, so we can do this analysis in multiple ways. One thing we can do is what, we can try to simplify this green color network with its Thevenin equivalent, and to get the Thevenin equivalent you can do source transformation. Okay, so 10 amperes in series with 2 ohms can be replaced with 5. I mean, the point is what, I think this 2 ohms is what, inconsequential. 2 ohms is what, inconsequential, because whether this resistance is what, 2 ohms or 5 ohms or 10 ohms, the current will always be the same. That is what, 10 amperes, because what is our point of interest? We are trying to find the value of I, and as far as I is concerned, whether this is what, 2 ohms or 5 ohms or 10 ohms, it doesn't make a difference, because it is in series with a current source. Okay, so current source in series with resistance from the external circuit point of view is as good as what, just the current source alone. Okay, look at this. So we have what, the original 10-volt source in series with some unknown resistor alpha, and then this network we are going to replace it with its Thevenin equivalent, okay, which is 1 ohm, and then this 2 ohm is immaterial. So I'll just show the 10 ampere current source. Now we can do source transformation on this sub network. So 10 amps in parallel with 1 ohms will become what? After source transformation, it becomes what? 10 volt source in series with the same 1 ohm resistor, okay. So remove this 1 ohm resistor, add the same 1 ohm resistor here, and then what? This current source becomes what? A voltage source of value 10 volts. That's all. This is how the network can be simplified. Once again, the original goal is to find this current I. Now if you notice, on one side we have 10 volts, on the other side also we have 10 volts. So no matter what the value of alpha is, the current in this circuit will be 0, because the net voltage drop across the circuit is what? 0. So this 10 volt source and this 10 volt source will cancel out each other, resulting in a net current of 0, which means I is also what? 0. So whatever be the value of alpha, whether it is 1 ohm or 1 kilo ohm or 100 mega ohms, the value of I will always be 0. If the value of I is 0, then power drawn from the source or power delivered by the source will also be always 0, irrespective of the value of alpha, okay. So let's move on to the next question. What is given here for the circuit shown, okay, for the circuit shown. So this circuit has got one coil, second coil, third coil. So altogether we have 4 inductors, each of value 1 Henry. I think we have a switch which is open for a long time and closed at t equal to 0. So they are saying that at t equal to 0, the switch is what? Closed. Then the time constant is dash. Well, I believe the units must be seconds, and also the time constant, probably they are asking it for t greater than 0. So first of all, for t greater than 0, the switch is what? Closed, okay. So the switch, it is what? Closed. And while finding time constant, you can make all the independent sources 0, which means this 1 ampere current source, you can make it 0. And clearly these two coils are in parallel. One parallel one is what? 0.5, and this parallel combination, it is in series with this coil and also this coil, because the current source will become open while finding the time constant, okay. So effectively we can replace all the 4 coils with one single coil with an equivalent inductance of 1 plus 0.5 plus 1, which is 2.5 Henry. Yes. And then of course even the 2 resistors will be in series, resulting in an equivalent resistance of 2 ohms, okay. That's all. The question is what? Find the time constant. So for a RL circuit, you know, so the circuit, it is what? A first order circuit. In fact, it is what? An RL circuit. And you know, for an RL circuit, the time constant is what? L equivalent by R equivalent. What is L equivalent? 2.5 Henry. R equivalent is what? 2 ohms. 2.5 by 2, which is 1.25 seconds. 1.25 seconds. All right. Let's move on to the next question. So what is given in this question? This circuit is given. In the circuit shown, ZTH is dash. Maybe the units are ohms. ZTH is how many ohms? So what is ZTH? It is the Thevenin impedance or the equivalent impedance seen looking in this direction, okay. So here, what is the context? So what's the context here? So this is like the source, and this is what? Our network. So we have a network which is linear. So we have a linear one port network across which some source is connected, some AC source is connected. So ZS is what? The source impedance, okay? And from the source point of view, what is the equivalent impedance of this network? That is what is Thevenin impedance. Now what does our network contain? It contains 3 resistors and also this pair of coils which are magnetically coupled. Even the mutual inductance value is given, and also this capacitor of value 50 microfarad. And what is the operating frequency? It is 5000 radians per second. I mean, it is quite simple. It's about finding what the equivalent impedance of this network on the right. So we have this pair of coils, right, which are coupled. Also the dots are shown, okay? So it is what? The case where the fluxes will get added, or the fluxes are going to be additive. So just to simplify the analysis, so this pair of coils can be replaced with an equivalent T-shaped network containing 3 independent coils. Right now the 2 coils are coupled, but this can be replaced with 3 separate or independent coils arranged in the shape of what, or in the form of what? A T-shaped network. So for that you can call this L1, you can call this L2, and the mutual inductance you can call it what? M, okay? Look at this. So first we have the 4 ohm resistor. Again we have what? The 4 ohm resistor, followed by the 2 ohm resistor. So this has been run without any modification. Now comes the modification. So this pair of coils is going to be replaced with 3 independent coils, okay? So what is the value of this? It is M. What is the value of this? It is L1 minus M. What is the value of this? It is L2 minus M. Yes. And then of course we have the original capacitor, whose value is what? 50 microfarad. Let me write it properly. Yes. So what is L1 minus M? 125 minus 5. So this is what? 120 millihenry. What is L2 minus M? 1 minus 5. This is what? Minus 4 millihenry. What is M? It is 5 millihenry. So it is what? 5 millihenry. I hope this is clear up to this point. Now, because the frequency is given for every reactive element, we can write the corresponding impedance. We can write what? The corresponding impedance. సార్ ఒకసారి ఆడియో వస్తుందో చూడండి, ఓబిఎస్లో వస్తుంది కదా? ఓకే ఓకే రైట్. So what is the frequency? It is 5000 or 5 kilo radians per second. So at that frequency, what is the impedance of the capacitor? Yes, it is what? 1 by j omega c. Omega is what? 5000. C is what? 50 into 10 power minus 6. Okay, 1000 into 10 power minus 6 is what? 10 power minus 3. We'll go to the numerator to become 1000. 1000 by 50 is what? 20. 20 by 4 is what? 4. 4 by j is what? Minus j4. Minus j4. So what is the impedance of this? It is minus j4 ohms. What is the impedance of this one? This minus 4 millihenry. See, this inductance, even though it is what? Negative, it is only what? An equivalent inductance, which can be negative. Okay. So what is the impedance of this one? J into omega into L. So 5000, 1000 and milli will get cancelled. 5 times 4 is what? 20 with a minus sign. So this is what? Minus J20 ohms. What is the impedance of this? Again milli and 1000 will get cancelled. So this is what? J25 ohms. Okay. And what is the value of this impedance? 120 millihenry. Again milli and 1000 get cancelled. 120 times 5 is what? 600. So this is what? J600 ohms. This is minus J20, this is minus J4. Now this one and this one both are in series. So what is the net impedance of this branch? Minus J24. Now this minus J24 and J25 are in parallel. So what is the net impedance of this parallel combination? It is what? J25 parallel minus J24, which will be J25 into minus J24 upon J25 minus J24, which is simply J. So J and J will get cancelled. 25 times 24, 100, 50 plus 10, 60. So this is also minus J 600. Yes. So what is the impedance of this subnetwork? It is minus J 600. So this is what? Sorry, minus J 600. Now this minus J 600, is it not in series with plus J 600? So what is the net impedance of this entire reactive network? It is what? 0. So the point is what? At this particular frequency, this entire reactive network will have a 0 impedance. Will have what? Will have what? A 0 impedance. నడుస్తుంది కదా సార్? చూడండి ఒకసారి. నడుస్తుంది కదా? Okay. So at this operating frequency, this entire reactive network will have 0 impedance, which means what? We can replace this with a short circuit. So just to get a clear picture, I'll just replace this entire reactive network with a short circuit, because the effective impedance is what? 0. That's all. Now what is ZTH? You have 2 and 4 in parallel, and that is in series with 4. So 4 plus 2 parallel 4. What is 2 parallel 4? 2 into 4, 8. 8 by 6 is what? 4 by 3. So 4 plus 4 by 3, which is 12 plus 4, 16 by 3. 16 by 3 is what? 5 point. So this, I believe, is the final answer. 5.33 ohms. It is the Thevenin impedance of this network on the right, as seen from this source point of view. Okay. Moving on to the next question. Two networks P and Q are cascaded, and its resultant network after cascading is what? Network R. And for network P, the Z parameters are given, and for network Q, the Y parameters are given. So it is to be understood that we are cascading two separate two-port networks. Yes. For the first two-port network, the Z parameters are given, and for the second two-port network, Y parameters are given, and for the resulting network, the ABCD parameters are alpha, beta, gamma, and delta, the value of beta. So this beta is what? B. Okay, ABCD beta is what? B. Okay. So let me just so there is one network which is connected in cascade with another network, and for the first network, the Z matrix is given, and for the second network, the Y matrix is given, and for this overall network, for this overall network, which is also another two-port network, you must find what? The ABCD parameters, not all ABCD parameters, only this B or beta. So whenever networks are connected in cascade, what we can conveniently do is what? To multiply the two ABCD matrices. but then we don't have the ABCD matrices of the individual two-port networks. For the first one, the Z matrix is given. For the second one, the Y matrix is given. So what you should be doing is to get the ABCD matrix from this Z matrix and also get the ABCD matrix of this one from its Y matrix. Once you get the two individual ABCD matrices, then you can find this B. So the easiest way to find the ABCD matrix of each two-port network is by simply manipulating the equations. Okay. So if you take the first network for which the Z parameters are given, so I'll just try. Let's see if I can get the final answer or not. Okay. See, for the first network, the Z parameters are given, and they are what V1. I mean, what are the two defining equations of Z parameters? V1 equal to what? Z11 I1, which is 40 I1 plus Z12 I2, and that is 60 I2. And the second equation that can be written as what? V2 equal to Z21 I1, which is 80 I1 plus Z22 I2, which is 100 I2. Understood? So from this set of equations, we will try to find the ABCD matrix or the ABCD parameters. What are those equations corresponding to ABCD parameters? The dependent variables are what? V1 and I1, and the independent variables are V2 and I2 or V2 and minus I2. Okay. So if you take the second equation, I1 can be written as what? 1 by 80 times V2 minus 100 by 80. 100 by 8 is what? 10 by 8. 10 by 8 is what? 5 by 4. So minus 5 by 4 I2. Yes. So there is one equation. And if you take the first equation, V1 equal to what? 40 I1. So in place of I1, we'll write this 1 by 80 V2 and then this minus 5 by 4 I2. So 40 times 1 by 8 is what? 1 by 2. So 1 by 2 V2. And then 40 times minus 5 by 4. 40 by 4 is what? 10. 10 into minus 5 is what? Minus 50. Minus 50 I2 plus 60 I2. So this can be further simplified as what? V1 equal to what? 1 by 2 V2 minus, no, not minus, plus I think I can write it this way. So this will actually be what? Minus 50 plus 60 is what? Plus 10. But that plus 10, I'll deliberately write it as minus of minus 10 times I2. Yes. Now, this is my first equation, and this is my second equation. Okay. So what is the first equation like? V1 equal to what? AV2 minus BI2. So what is A? 1 by 2. What is B? It is minus 10. Okay. Let me. So for this first two-port network, the ABCD parameters are going to be what? 1 by 2 minus 10, and then 1 by 80 and 5 by 4. Okay. 1 by 80 and 5 by 4. This is what the ABCD matrix of the first two-port network. In the same way, we'll also try to find the ABCD matrix of the second two-port network for which the Y parameters are given. And the Y parameters are what? 5 minus 2.5 minus 2.5 and 1. Okay. Five minus 2.5 minus 2.5 and 1. Just verify. 5 minus 2.5 minus 2.5, 1. Now from this y matrix, let us try to deduce the ABCD matrix. Because y parameters are given, what are the defining equations for y parameters? I1 equal to what? y11 v1 plus y12 v2. y11 v1 means what? 5v1 minus 2.5 v2. Okay. So this is one equation. Another equation that we can write is what? I2 equal to y21 v1, which is minus 2.5 v1 plus y22 v2, which is plus v2. Now if you take the second equation, this can be written as what? v1 equal to v1 equal to what? 1 by 2.5 v2. Is that correct? 1 by 2.5 v2 and then minus 1 by 2.5 I2. I think this is correct. Okay, minus 1 by 2.5 I2. So now we have what? V1 in terms of V2 and I2. Break ichi appudu signals. Okay, and then you go to the first equation. I1 equal to what? 5 V1. In place of V1 we can write this. When you do that, 5 times 1 by 2.5 is what? 2 V2, and then again 5 times this is what? Minus 2 I2, and then you have this minus 2.5 V2. So this equation will be what? I1 equal to 2 V2 minus 2.5 V2 is what? Minus 0.5 V2, and then minus 2 I2. That's all. Now please look at this equation and also this equation. V1 in terms of what? V2 and minus I2. I1 also in terms of V2 and minus I2. So from this we can straight away form the transmission matrix of the second two-port network. Okay, and that would be 1 by 2.5 minus 1 by, not minus 1, plus 1 by 2.5. Yes, and again this is what? Minus 0.5, and this is what? 2. That's all. So for the first two-port network, the ABCD matrix, earlier we found it as what? This one. Okay, and for the second one we just found the ABCD matrix as what? 1 by 2.5, 1 by 2.5, minus 0.5 and 2. If there is any mistake that I have made, you can please let me know. So I'll just write this on the earlier slide. 1 by 2.5, 1 by 2.5, minus 0.5, 2. One by 2.5, 1 by 2.5, minus 0.5 and 2, minus 0.5 and 2. That's all. So now for each of the two-port networks, we have the individual ABCD matrices. Okay. Now for this cascade, you have to find what? B. So B is what? Here. B is what? Here. So beta is nothing but B. And what is its address? It is in the first row in the second column. Okay. So you have to multiply first row of this with the second column of this. Okay. So 1 by 2 into 1 by 2.5, and then plus minus 10 into 2. Yeah. So 1 by 2 into 2.5. 2 into 2.5 is what? 5. 1 by 5 is what? 1 by 5 is 0.2. So 0.2 minus 20, which is minus 19.8. So that's the value of B that I am getting. Okay, minus 19.8. So that's it. These are all the questions from network theory or electric circuits. We'll take a small break, and after that I will take you through the signals and systems questions quickly. I will only present the answers because our faculty MY sir is not available here. We have sent him the questions and we have received the key from him. So I will just walk you through the questions. I will put the, I'll just mark the answers for every question. After that, Giri sir will take over and complete power systems subject. Okay. Break. హలో వస్తుంది కదా ఓకే సో దిస్ ఇస్ ది ఫస్ట్ క్వశ్చన్ ఫ్రమ్ సిగ్నల్స్ అండ్ సిస్టమ్స్ which one of the following options is always true for the convolution of x of t and y of t okay so for this question the answer is what it is an even signal again I am just reading out the answers which have been sent by our MY sir okay so for this question y of t equal to what e power minus t times this integral from minus infinity up to plus infinity. The system is, pick the correct option, it is what linear but not time invariant okay. Let x of omega be the Fourier transform of the signal e power minus t power 4 and then cos t where t can range between minus infinity and plus infinity. The value of the derivative of x of omega at omega equal to 0, the answer is what 0 okay. So there are two discrete time signals T1 and T2 defined as like this and like this. Which of the following statements is true? This is an MCQ question, only one option is correct. So the correct option is what? Option B okay. Look at the next question. If the Z transform of a finite duration discrete time signal x of m is what? Capital X of Z. The Z transform of x of 2n is which one? It is what? Option B is this option okay. If the energy of a continuous time signal x of t is E and the energy of the signal 2 times x of 2t minus 1 is what? CE, then the value of C is what? 2. The answer is what? 2. That's all. These are the 6 questions from signals and systems. Yeah, later, I mean in a couple of days, probably tomorrow or day after tomorrow, we will provide detailed video solutions for these signals and systems questions, yes, of both electrical as well as EC. Okay, for now, we are only providing the key. So next subject will be power systems, which will start very shortly. Okay.
Okay, now we'll start with power system questions. Let's see this question. This is actually MCQ question given for 2 marks. If you read the data and if you try to solve the question, it is actually a bit lengthy question. But using common sense, we can easily answer this question. Okay, let's see what is given actually here. So a 3-phase, a 3-phase 11 kV 100 MVA synchronous generator is connected to an inductive load of power factor √3/2, basically lagging, okay, via lossless line, and the per phase reactance of lossless line also given 5 ohms. That means the resistance of the line is what neglected because it is not given. The synchronous reactance of the generator is given 30 ohms, okay, and resistance of the generator is negligible. So if generator is producing rated current at rated voltage, the power factor at terminals of the generator is. Let me draw the circuit first so that we can easily answer. Okay, now the equivalent circuit of the generator in a per phase form. How to write? A voltage source in series with reactance, right? Now this is what the terminals of the generator, where he is asking the power factor, right? Now there is a transmission line. After that there is a inductive load, but careful, it's not a pure inductive load. How can I say it's not a pure inductive load? Because the power factor for pure inductive load is 0. Okay, it's just an inductive load. Inductive load means it has some internal resistance. So it's basically an RL load. Okay, let me draw an RL load here. Now just think about the power factor at this point. At this point is given. How much it is? √3/2. √3/2 means what? It's a 0.866 lag. 0.866 lag. Okay, the power factor at this point is 0.866 lag. Now what is the power factor at this point is asking. A very simple way to answer this question is, let's see what is the power factor formula. So I can write like this. The power factor, the fundamental formula is cos of tan inverse Q/P. The Q at that point divide with what? P, tan inverse of that will give you the power factor angle, and that cos of that will be the power factor. Okay, clear? Now let's see here. So one simple thing, simple mass. If Q increases, just imagine, if Q increases, tan inverse of that, that means the angle will increase. If angle increases, cos of that angle will what? Decrease. But if you see in this circuit, really Q is increasing if you see from here, because he is asking the power factor at this point. That means I should know what is Q here, what is P here. Very simple. So P here will same. Why? Because in between we have a reactive circuit. P here is same. But what about Q here is greater than the Q here. Why? Because okay, RL load is consuming some reactive power. In between, since we have a reactive network, this reactive network also consumes some reactive power. So that means overall Q is what now? If I see from here, overall Q is what now? Greater than the Q here. So Q is increasing. If Q is increasing, then tan inverse Q/P, we get higher angle. Then power factor is what now? Decreasing. So the answer should be, the power factor is definitely less than 0.866 and it should be lag. The overall power factor at the terminals of the generator is definitely lagging but not leading. Okay, so it should be less than 0.866. So what option is saying that? So only one option, that is A. Okay, so 0.87 lag, it's not possible. Leading is not at all possible because we have a reactive network in between. Okay, 0.87 lead, that is also not possible. Okay, but if you try to solve this question using the data given, like the calculating the current, calculating the voltages and powers, definitely, so you will end up with what? A very big solution. Okay, so definitely you will be in trap and you can waste your time. So this is the question you can answer with a common sense. Okay, now we'll move on to the next question. Now, so this is the question given from economic load dispatch. So I used to discuss this kind of questions regularly in the classroom. Okay, so even the economic load dispatch, every time we can expect one question. It might be from maybe 1 mark question or it might be a 2 mark question. Okay, but it is a bit tricky question, okay. If you notice here what is mentioned, the incremental cost curves of two generators are given, okay, cost curves are given here, right. So the incremental cost when supplying a common load is given 7,400 rupees per megawatt hour. So if you identify where is that 7,400 on the graph, I will get somewhere here. Let's see. Yeah, I'll get somewhere here, 7,400 somewhere here. Okay, if you really notice here, it is meeting the generator A curve somewhere here. Somewhere here it is meeting the generator A curve, but it is not meeting the generator B curve. Okay, suppose if I want to have an intersection with generator A curve, I need to extend the line like this. Let's see. I'm just trying to have an intersection with generator A curve. Then I need to extend the line like this. I can do that. But maybe where it is touching, it may be touching what? Less than 0. But minimal limit for A and B are what? 0. Because the curve is starting at what now? 0 megawatt and ending at what? Somewhere here, that is I can say 150 megawatt as per the graph. So that means the minimal limit for A is 0 megawatt and maximum limit is what? 150 megawatt, and minimal limit for B same as minimal limit of A, that is 0 megawatt, and maximum limit of B same as maximum limit of A, that is 150 megawatt. Now if you notice, as per the common incremental cost, if I want to calculate what is the generator B output, that will be less than 0. But practically it is not possible because the generator B cannot supply cannot supply a power which is less than the minimum limit. I am saying the minimum limit for both A and B are clearly mentioned from the graph, that is 0 and maximum limit is what? 150 megawatt. At any cost, the generator A and B should not supply less than 0. Right or not? But as per the common incremental cost which is given, if I extend this curve, if I extend the curve like this, what I get? Less than what? 0 megawatt. That is not possible. That's why. So I need to say the output of generator B, okay, this is for generator B curve, right? The output of generator B should be 0 megawatt. See, this is the logic you should know to answer the question. Now how to calculate the generator A power output? Using the equation. If I add A and B, that is the demand. So we need to answer for what? Demand in megawatt, right? That is PA plus PB. PB is straight away 0 megawatt because the common incremental cost curve not having an intersection with generator B curve, but it is having an intersection with generator A curve, right? Now at this point, what is the power output I need to calculate? Okay, for that I need to find out the incremental cost equation for generator A. Since it is a straight line and we have 2 points, so using those 2 points we can easily calculate the line equation. What is the line equation? Y equal to mx plus c. Y means what? Incremental cost axis. Incremental cost is equal to some m times, okay, incremental cost of generator A, that is equal to what? M times the power output of generator A plus some constant c, right? Now what is the slope? Slope means what? You know, y2 minus y1 by x2 minus x1. So let's see what is y2 here. So this point we know 1200, y1 6000, right? 1200 minus 6000, 1200, I'm sorry, 12,000, okay, it's not 1200, yeah, 12,000 minus 6,000 divided with x2 minus x1, the power output here 150, the corresponding power to the upper limit 150 and lower limit is what? 0. So what I get here, 6,000 by 150, that is what? 40, okay. So the slope is what now? 40. So now I can rewrite the equation ICA, incremental cost of generator A, equal to what? 40 times PA plus C. Now I want to find out the C. So I can use any point here. Either I can use lower limit point or upper limit point. Okay, better to use the lower limit point. If PA is 0, let's see. If PA is 0, what is incremental cost? 6,000. So using this, so 40 into 0, 0. So C equal to what now? 6000. From here I can get C equal to 6000. C equal to 6000. Now I can write the equation. So incremental cost equation of generator A is equal to what? 40 times PA plus 6000. 40 times PA plus 6000. Okay. Now at what incremental cost he is asking? The demand at 7400. So if you substitute, incremental cost is what? 7400. 7400, that is equal to 40 times PA plus what? 6000. Okay. If I solve this, I will get PA equal to 35 megawatt. 35 megawatt. Now what is the demand now? PA plus PB. So PA is 35, PB is anyway 0. So I will get the final answer is 35 megawatt. So the answer for this question is 35 megawatt. It's just a 1 mark question. You need not to find out the generator B incremental cost curve. It's just a common sense that what? There is no intersection of what? The common incremental cost with generator B incremental cost curve. That's why. So we have to set it to its minimum value. Okay. So minimum value is what? 0 megawatt. Okay. So this is how you need to solve, because it's just a 1 mark question. Okay. You have to complete the solution quickly. Right. Now we'll move on to the next question. Yeah. So this is the one question I can say it's a bit tricky question, because we didn't discuss this kind of questions in power system. Okay. Because if you see here, it's a two-phase network. Okay. I can say this is a question from networks. I can say this is the question from power system, and also we need machines background to answer this kind of question. Okay. I'm reading again. For a two-phase network, phase voltage Vp and Vq. It's a network. I have some two-phase network. Okay. Clear? There is a phase voltage. Two-phase network means what? We are giving two voltages. Just like three-phase network, we are giving three phase voltages, VR, Vy, Vb. Like two-phase network, we are giving two voltages, Vp and Vq, right? It's just a network. Vp and Vq we are giving are expressed in terms of sequence voltages V alpha and V beta. Okay, clear? Suppose in a three-phase system, what we do? Va, Vb, Vc, these are what? Unbalanced voltages. We can write in terms of what? A transformation matrix times what? Zero sequence, a positive sequence, and what? Negative sequence. But it is a two-phase system, right? It's a two-phase system. You know, as per the symmetrical components theory, a two-phase system can be resolved into what? Two balanced system of phasors, but not three. That's why this is not correct here, because it is a two-phase system, right? Then how to tackle this question? Let's see. So as per the question, once again, if I see, so these are the unbalanced voltages. Vp and Vq are what? Unbalanced voltages. V alpha and V beta are what? Symmetrical components voltages. Okay, clear? So this kind of questions we are not discussed in power system. Generally, these kind of things are not discussed in power system. Okay, to answer this question, we need some machines background. Okay, better to answer these questions from the machine's point of view by taking an example of a split phase induction motor. Okay, so to answer this question, now I will take the help of Surendra Reddy sir. Okay, so he's our machines faculty. All of you know about this. Okay, so sir will take up this question, and parallelly I will also discuss with the sir how to tackle this question at the end, because it's a mix of what? A network and what? A machines concept question. Okay, now sir will continue. Sir.
Yeah, all right. So first of all, we need to understand it is an MSQ question. So more than one option may be correct. In fact, we can get 4 different answers for this particular question. See, it was a two-phase network having two phase voltages Vp and Vq, as sir has already explained, and it has two sequence voltages. One is V alpha and another one is V beta. So normally in three-phase network, we use it to have 3 sequence components, right? Zero sequence, positive and negative, but in two-phase unbalanced system, only two sequence components will be available, which are nothing but positive sequence component. Another one is negative sequence component. You don't find zero sequence component in unbalanced two-phase systems. Now, why I am here to explain this question is because we cannot answer this question straight away from electrical circuit point of view. What we will try to do is that we will try to incorporate some machines, basics, so that we can answer the question easily. Okay. So, in which machine we will generally observe a two-phase system? Yes, obviously the answer is induction machines, right? So, especially if you consider split-phase induction motor, we used to have two windings known as main winding and auxiliary winding, isn't it? So, this main winding and auxiliary winding were displaced by 90 degrees space angle. Okay. So, now let me try to draw a simple network. All right. So, here let's say this is going to be the main winding of the machine and this is the auxiliary winding of the machine. So, what I am doing here is that I am assuming this main winding is at a space angle 0 degrees and this auxiliary winding is at a space angle of minus 90 degrees. That means I am assuming auxiliary winding was space displaced by 90 degrees lagging. But you can have one more choice here. You can take auxiliary winding leading main winding by 90 degrees. That is why it is an MSQ question. Okay, more than one option is there. Okay, so this is my first choice. I am taking auxiliary winding lagging the main winding by 90 degrees, and don't forget this is a space angle. Okay, now so let's assume that this main winding is supplied by first phase voltage Vp and this auxiliary winding is being supplied by second phase voltage Vq, isn't it, sir?
But
So,
one
yeah.
small correction, sir, because anyway it's mentioned Vp and Vq, right? So we will take another voltage here so that representation become simple. You
Okay.
can take it V1 and V2. and
No
then we will
problem.
write
No problem, sir. So we can even consider this is V1 or this is V2.
V2.
All right. So any terminology we can use. Ultimately we can replace, right?
Yeah,
Okay. So now what our aim is that, as given very clearly in the problem, that the voltages are unbalanced. So we have to write the resultant voltage as a combination of positive sequence voltage and negative sequence voltage. So I am taking this V1 voltage as reference, guys. Okay, that is 0 degrees, and don't forget that this theta 0 degrees is space angle, this voltage 0 degrees is time angle. Understand? So we have two variable parameters here, and this theta minus 90 degrees is space angle, and whatever the angle this voltage has, that will be time angle, and most importantly this is not 90 degrees exactly. Why? Because the given voltage is unbalanced two-phase voltage, so you can't guarantee exactly 90 degrees here. That is why we are using sequence components. Okay, so now V1 can be written as one positive sequence component and negative sequence component according to the question. I think
V alpha and V
so some terminologies were mentioned, right, sir? What is that? V alpha and V beta. Okay, all right.
So V alpha is positive sequence voltage
So-
and V beta is negative sequence.
Yeah, so the first phase voltage V1 is equal to positive sequence voltage V alpha, negative sequence voltage V beta. Okay. Similarly, the second phase voltage V2, this should be again combination of positive sequence voltage and negative sequence voltage. But remember, positive sequence means it will create which type of rotating magnetic field in the machine. Yes, we know that positive sequence supply will always create forward rotating magnetic field. That's why second phase voltage will be 90 degrees in forward direction. Forward direction means 90 degrees leading. So that's why it will become JV alpha, isn't it?
Yes.
And coming to V beta, beta is a negative sequence component. Negative sequence component will create a rotating magnetic field in backward direction. Backward direction means it should be lagging by 90 degrees. So it must be minus JV beta. But point is, these two equations are valid from machine point of view. Understand or not? Okay, not from power systems point of view. These two are with respect to machine's point of view. Okay, that means first winding is at 0 degrees space angle, second winding is at minus 90 degrees phase angle. Now I think, sir, to
space angle,
compensate
please.
this 90 degree space angle,
With respect to
yes, the second winding we have to multiply with plus 90 degrees, right?
yes, plus 90 or minus 90.
Minus
If you take
90.
there, it's a minus 90.
Okay, suppose if I take this is plus 90,
Okay.
let's start with this assumption. This is 0, this is plus 90. Then to compensate this plus 90,
We have to multiply with
minus 90. Minus 90 means second equation we have to multiply with
minus j.
plus j or minus j?
Minus j.
Minus j. Okay, right. So, so this second equation will be modified. V2 will be,
We will write in the circuit point of view, sir. Now, just
Okay.
you take this small correction, guys. Yeah, from the circuit point of view,
sorry.
from the circuit point of view, see, we want to write VP. What is VP? As it is V1, right? So that is V alpha plus V beta, right? From this VQ, you know, so as sir mentioned, it is a space displacement 90 degrees, but circuit, there is no concept like space displacement. Okay, space displacement already taken here, that's why we got this equation. So to again compensate that phase displacement, I need to multiply with what now? Minus j. So minus j times what? V2. So if I do that, what I get now? Minus j into j, that means 1 plus 1. So that means we get V alpha, and minus into minus plus j into j, again minus. So directly I am writing minus V beta. Okay. Now if you write in the matrix form Vp and Vq, okay, that is equal to, let's write here Vp and Vq in terms of what? V alpha and what? V beta. See, that is what the original question. And as per the question, this matrix he is saying yes, and is asking for what? The matrix S only. So here 1, 1, because V alpha plus V beta. Here what? 1 and what? Minus 1. So one possible option for this question is 1, 1, 1 minus 1. So the other possible question options also possible here. So the sir will explain that. Okay, clear.
yes. As I mentioned, there are two variable parameters here. One is time angle, another one is space angle. Okay. So in the first case, let us say this is like case number 1. What is the first case assumption? Main winding was at a space angle of 0 degrees and auxiliary winding was at a space angle of plus 90 degrees. So I can take the second assumption. Main winding is at an angle 0 degrees and auxiliary winding is at an angle minus 90 degrees. Okay. Then equations will change. See that? So now the assumption is main winding is at a space angle of 0 degrees. Auxiliary winding is at a space angle of minus 90 degrees. But a time angle I am not disturbing, guys. I am taking still the first voltage as reference. Okay. Second voltage angle I don't know because it is unbalanced supply. So what will be the equation for V1? V1 is nothing but Vp, first phase voltage. So it is simply V alpha plus V beta. Okay, positive sequence, negative sequence. Now second voltage, which is something VQ, it is lagging by 90 degrees, right? Okay, so therefore V alpha will become minus j V alpha, V beta will become plus j V beta. Understand? Okay, so now I have to compensate this 90 degrees back to electrical circuit so that this 90 degrees can be compensated by multiplying with plus 90. Indirectly I have to multiply with plus j.
So that means you can just eliminate this.
Right.
Just V2. This is, you can cut it.
Okay, no problem. VQ. This equation will change. So I have to multiply with plus j minus j V alpha plus j V beta. So minus j into plus j square, that is nothing but V alpha, plus j into plus j square, that is nothing but minus V beta. So I think once again we are going to get the same answer. Vp and VQ is equal to, yes, it is 1 plus 1, this is 1 minus 1. So this is V alpha, this is V beta. I think even in the next previous case also we got the same matrix, 1, 1, 1 minus 1. Even in the next case also 1, 1, 1 minus 1. So therefore, whether you take auxiliary winding is 90 degrees lagging or 90 degrees leading, the matrix is going to be the same, 1, 1, 1 minus 1. So therefore, definitely in the question, 1, 1, 1 minus 1. So where is it, sir? 1, 1, 1 minus 1. Yes, sir.
Actually, there is a small correction
Yes,
in the
there
options.
is a small correction, guys. Just let me check. There was a typing error, I think. No, sir. 1, 1, 1 minus 1, right? So this option A has a typing error. Yes. So this actually 1, 1, 1
minus
minus 1. Second option, sir.
Second option, all ones, correct.
Okay.
Fourth option, correct. And
third.
fifth option, 1, 1, 1, 0. Okay, right.
Right. So therefore, definitely this option A is going to be the correct option. Okay. But it is an MSQ question, guys. So there is one more possibility is there. The other possibility is, you see, in this particular first case and second case, space angle I modified. What I did here is that first case, main winding 0 degrees, auxiliary winding plus 90. Second case, main winding 0 degrees, auxiliary winding minus 90 degrees. But remember, in both cases, time angle I did not change. In both cases, you see that first phase voltage I took as reference voltage. Understand or not? Even in the second case also, first phase voltage I took as reference. Therefore, in the next case, what I will do is that same theta angles I will consider. Again, two cases I will get. But this time, I will take V2 as reference.
Yes.
And V1 will become a different angle, isn't it? Okay. So if I proceed further,
No need to proceed, sir. Directly,
we can write down.
we can write down the answer.
So so this is the main winding now. This is the auxiliary winding. So this is space angle 0, space angle plus 90. But coming to the time angles, this time we are taking V2 as reference, right? Isn't it?
Yeah.
So therefore, V1 equation will become V2 equation. V2 equation will become V1 equation. Again, two cases will come. The next case is probably main winding is at 0, auxiliary winding is at minus 90. V1 is going to be, sorry, V2 is going to be reference, right? So this is V1. So that we can directly write down what is going to be the next possibility. Yes, sir. So what is the probability? So VP, VQ, indirectly V1, V2.
Now you can cross verify this.
You can cross verify this.
Directly write it.
So
Minus 1,
we will get,
this answer.
yes, this one. C, minus 1, 1, 1, 1. You can cross verify this. Same procedure. Minus 1, 1, 1, 1. V alpha, V beta. It is quite a difficult question. It is very rare. I think this is the first time we got unsymmetrical components from two-phase system. Okay. Usually questions will come from three-phase system. So that's why from the machine knowledge we tried to answer this question. Okay. All right. So I'm handovering the session to Giri sir again.
Okay. Right, sir. Thank you, sir. Right, we'll move on to the next question now. So that's about this question. Yes, it's a bit lengthy question. In the exam, if you want to solve now, it's not so easy. Since it is an MSQ question, many of my students after the exam contacted me. They given the right answer because they followed some elimination procedure. Okay, even I want to discuss that very quickly. Okay, so that is okay. Even I say, yeah. See, this option is not correct. Why? Because inverse is not exist for this. Yes or not? Because determinant is what? 0. Because when you are writing unbalanced voltage in terms of symmetrical components, reverse also should be valid. That means we can write sequence components in terms of unbalanced voltage. For that you have to inverse the matrix, S inverse. So this option straight away we can eliminate. Since the system is what? Unbalanced, that's why both positive and negative sequence components should exist, right? But apart from the option D, if you notice, so there is what now? 0 here, right? the positive sequence component is what? Existing, but negative sequence component will not exist. That's why this option also I can eliminate. So only these two options, okay, are correct, right? So maybe sometimes the people may say that maybe out of these only one option might be correct or two options might be correct. Some people may think like, so since it is an MSQ question, maybe more than one options should be correct. There is no rule like that, okay? In case of MSQ question also, one option might be correct here, okay, right? So some people are answered like A, some people are answered C, some people are answered what? Both A and C using some elimination procedure, because since there is no negative marking for MSQ questions, okay, clear? So in the exam, yes, you can use this kind of tricks, because so whatever we discuss using machines concept, it's a really lengthy procedure. Since we need to get the right procedure, that's why we discuss like this, okay, right? Anyway, you can answer the question like this also. So we'll move on to the next question now. Yeah, this is the question related to the load frequency control and automatic voltage regulators. So you know, in power system we generally use what? In power system we generally have a control of voltage and what? Frequency, right? So generally to control the frequency, everybody knows we use automatic generation control system, and to control the voltage we use automatic voltage regulator, correct or not? See, to control the generation, the mechanical input of the generator will be adjusted. Everybody know about this, very simple question. And to control the voltage, we need to control the excitation by increasing or decreasing the field current, okay? So AGC controls what? Mechanical input of the generator, and AVR controls what? Field current or excitation, I can say in short excitation, okay? Now if you see the options, since it's a MSQ question, again more than one options may be possible, Let's see first option here, AGC responds for global effect on frequency. So we discussed n number of times in the power system class. I told you frequency is a grid parameter, it's a global parameter. Throughout the grid, throughout the interconnected system, frequency will same, okay? Suppose we have a n number of generators generating the power to, let's say, Telangana state or Telangana grid. So throughout the Telangana state the frequency will same. If the frequency decreasing means what? It is an indication of what? Generation less than the demand. So automatically all the generators will try to increase the generation. All the generators will try to increase the generation by increasing its mechanical input. So what you can understand from here, since the frequency is a global parameter, so AGC control is a global response. It's not a local response. It's not that frequency of one generator will vary. Since it is an interconnected system, all the generators are operating at what? Same frequency. It's just a simple fundamental in power system and electrical machines. Everybody know about this. So that's why a frequency control is a global response. But whereas voltage is a local parameter. Simple example, in my house the voltage is, let's say, 230 volts. Maybe after my house, if I, let's say, go for 11th house, the voltage may not be exactly same. It will be slightly less or slightly more, because the voltage drop up to my terminal, voltage drop up to what? The 10 houses later, that terminal, you just compare, it will not be a same one. So that's why I can say simply voltage is a local parameter. At every bus in power system, we need to control the voltage by using reactive power compensation. So one way of controlling the generator bus voltage, where the generator is connected, that bus is called generator bus. So if you want to control the generator bus voltage, generally we control the excitation of generator, correct or not? So that's why voltage control is always a local phenomena, but frequency control is always a global phenomena. So that's why, so option A is correct. AGC responds for global effect on frequency, while AVR responds for local effect on voltage. This is 100% correct. Now this is the reverse option for option B. Sorry, option A. AGC responds for local effect on frequency? No. it will respond for what? Global effect on frequency. While AVR responds for global effect on voltage, no, it will respond for local effect on voltage. That's why this is not correct. Okay. Now, next see, AGC regulates field current of the generator. No, AGC regulates what? Mechanical input. So that's why this option I can straight away eliminate. AGC regulates the mechanical input of generator. Yes, AVR regulates what? Field current of generator. So that's why. So A and D are what? Correct here. Since it is a MSQ question, so yes, here more than one option may be correct. So that's why A and D are the correct options for this question. Clear? Now we'll move on to the next question. Let's see. This is a question related to the concept of power system stability. Okay. Now, this is a bit lengthy question, but many people are failed to answer this question by seeing the data. The people are thought that what? It's a very big data is given, so we are unable to answer this kind of question. But it's really a simple question if you understand the question in step by step. Let's see what is given here. A single line diagram of power system is given here. First thing we can say, generator connected to infinite bus through transformer and what? Parallel circuit lines, or I can say double circuit lines. Okay. But no data is given on single line diagram, generator reactance, internal voltage, line reactance, transformer reactance, nothing is given. Okay. Now let's see. So that's why we need to depend on the data. Okay. So to find the logic behind the question, right? The power angle equation of the system is P max sine delta. Okay. So initially the power angle equation of the system is what? P max sine delta. P max sine delta. This is the power angle equation of the system initially, right? So the mechanical input to the generator under steady state is 0.5 P max. That means before disturbance came. Why I am saying a disturbance here? Because let's see, after this a statement is given, a fault occurs on line 2. Fault occurs on line 2. Ante before the fault occurs on line 2, what is the system condition? Steady state, stable, and delivering what? Electrical output, and that is equal to mechanical input, that is equal to 0.5 times the P max. Now this is what? Initial state of the system before the disturbance. Okay, I can say this is a pre-fault condition. Better. Pre-fault condition, this is the case. Now let's see during fault. During fault what is given? During fault, let's see what is given. A fault occurs on line 2 such that the power output of the generator is less than 0.5 times the P max. What is the meaning of that? So the power output is always, okay, PM equal to PE. Now that is always less than what? 0.5 times the P max. Okay. The power output is what? Less than 0.5 times the P max. So that information given, that is during fault. And what is post fault condition is given? If you notice, post fault condition. The post fault condition is given here. If you notice here, a fault is cleared by opening line 2. So that means fault is on the line 2. Now the line 2 is disconnected from the system. That is what I say post fault. The power output of the generator is P max by root 2 sine delta. That means now the power angle equation is what now? P max by root 2 sine delta. Okay. If critical clearing angle is pi by 2 radians, critical clearing angle is given pi by 2 radians, then the acceleration area on power angle curve is asking to calculate what is the acceleration area. So to answer this question, right, let me draw the power angle curve so that we can get some idea to answer this. Let's see. Yeah. So if you check here, this is pre-fault power angle curve. Now this is I am saying P max because the pre-fault maximum power transfer is P max, it's clearly mentioned. PE or what? PM, both are same. Okay. PE or PM equal to what? P max sine delta. And post fault also given. Post fault is what? What is the curve given? Post fault curve equation. If you notice, if you just go back, what is the curve? P max by root 2 sine delta. So that means what is the maximum value? P max by root 2. P max by root 2 means, shall I say 0.707 times P max? Yes. .707 times P max. Now, during fault, the power output will not exceed 0.5 times the P max. That means the maximum value is always less than 0.5 times the P max. So, power angle curve will be what now? Something like this. So, this is the 0.5 times the P max. This is the 0.5 times the P max. This is the mechanical input. That is also given in the problem. You can check. Before the fault, the mechanical input to the generator, that is definitely equal to electrical output, which is 0.5 times the P max. Okay? Yes, the PM, and that is equal to PE, which is equal to what? 0.5 times the P max. Now, after this, it's just a simple mass question. Let's see. See, this intersection point, if you see, this is what? 30 degrees I will get. Why? Because P max sin delta is the curve. PM equal to 0.5 times the P max. So that's why, that means PM equal to 0.5 times the P max. That is equal to P max sin delta naught. Why I am saying this is delta naught? This is what? Pre-disturbance power angle, sorry, pre-disturbance the load angle. Now tell me, P max get cancelled, delta naught equal to what? 30 degrees. That is before the fault. But during the fault we can't do anything because it's clearly mentioned this value is what? Less than 0.5 times the P max. Okay. But post fault, if the system is really stable, post fault means it is going to settle here. Now, what is this angle? What is this angle? I can easily calculate. The curve equation for this is what? Post fault, that is P max by root 2 sine. Okay, that settling point I am assuming delta 1. What is the delta 1? We need to calculate. That is equal to what now? Again same 0.5 times the P max. Now if you calculate delta 1, we get 45 degrees here. So okay, delta 1 also I got 45 degrees. Also, so I can eliminate whatever hold interconnected system, frequency will same. For the Telangana state, the frequency will same. If the frequency hello. Yeah. Okay, okay, I'll continue. Otherwise, sir. Again, say 0.5 times the Pmax. Now, if you calculate delta 1, we get 45 degrees here. So, okay, delta 1 also I got 45 degrees. Okay, sir. No problem. Okay, sorry guys, there is a problem with the mic. Now we'll continue. So yeah, delta 1 we got 45 degrees, right? Now what is delta max? We know, right? Delta max is always 180 minus delta 1. Delta max is what? 180 minus delta 1. 180 minus new stable equilibrium point or new steady state rotor angle. So 180 minus delta 1, that is what? So 180 minus 45, which is 135 degrees. So this is what our delta max. So what is happening here? So once after the fault, operating point will jump from here to here. Yeah, I'll use another color pen. Okay. Once after the fault, the operating point jump from here to here. This is a steady state operating point. Now during fault, this is a power angle equation now. The operating point will go here. Now mechanical power is what? Greater than electrical power. The rotor is accelerated, rotor speed increases, load angle will increase. Okay. So load angle is what now? Keeps on increasing. Now till this point, it is what? The system is under fault. Now exactly at this point, that is a clearing angle. Okay, is mentioned critical clearing angle, and that is what? 90 degrees. At this clearing angle, the fault is cleared. What is the meaning? Now this curve is no more now. Once the fault is cleared, then this is what? A post fault case. Okay. So pre-fault case, operating point is here. During fault case, operating point is on the power angle equation of during fault. Then after this point, then the operating point will suddenly jump from pre-fault curve to post-fault curve. Then there will be a deceleration now because electrical power greater than mechanical power, and rotor will be under forward swing. Finally, it will came up to here, up to delta max. Then after that, there will be a backward swing and forward swing and backward swing. Finally, machine will settle here if system is what? Stable. Okay. But we are calculating here critical clearing angle generally. But a question is given in a reverse way. Critical clearing angle is given and is asking to calculate what is the acceleration area. But we already know that to calculate the critical clearing angle, we equate acceleration area and what? Deceleration area. So this is the acceleration area and this is what? Deceleration area. Why I am saying this is an acceleration area? Here mechanical power is greater than electrical power. But why I am saying this is a deceleration area? Here electrical power is greater than what? Mechanical power. Now we need to equate these two areas and we need to calculate critical clearing angle. But what is the question? Critical clearing angle is given and is asking what? Acceleration area. But calculation of acceleration area is not so simple. For that, we should know the four boundaries. Yes, 30 to 90, two boundaries we already know, and PM value we know, that is 0.5 Pmax. But this equation we don't know because this curve equation in the problem it is mentioned what? Less than 0.5 times the Pmax. But exactly we don't know what is the value of that. It will be less than 0.5 times the Pmax means what? I can take any value, right? So that's why. So acceleration area is not possible to calculate from here. But the tricky part is we know that for critical clearing angle, acceleration area and deceleration areas are same. That's why let's solve for deceleration area. That is the answer for the question. Now, what is the expression for deceleration area? Acceleration area and what? Deceleration areas are same. A acceleration equal to what? A deceleration, because is given critical clearing angle. So that is equal to, I'm just writing the expression for only deceleration area. Electrical power boundary is what now? P max 3 sin delta. What is that P max 3 sin delta? We know post fault means what is given? P max by root 2 sin delta. Okay. So let me write here P max by root 2 sin delta. Right, minus, this is electrical power. What is mechanical power? Mechanical power is Pm, that value we know, 0.5 times the P max. With respect to delta, I am integrating. And what is the lower limit? 90 degrees. What is the upper limit? 135 degrees. Right, now if you evaluate this, we will get the answer in terms of P max. But in the question is asking the acceleration area is how much times of P max. Okay, P max you take it common, and whatever the number we got, that is the answer for this question. Let's do the integration for this. Okay, so I'm just writing here. So that acceleration area or deceleration areas are same, that is equal to P max I'm taking out. Now, so sin delta integration is minus cos delta. Okay, and minus 0.5, P max already I taken common, minus 0.5 integration will be minus 0.5 d delta, means delta, I'm sorry. Now if you substitute the limits, okay, so lower limit is 90 degrees, upper limit is 135 degrees. Okay, root 2. Okay, I'm sorry, by root 2 will be there here. Yeah, P max by root 2. Yeah, okay, sin delta by root 2. So sin delta integration is minus cos delta. Okay, now we'll substitute the limits. Right. If I substitute the limits, let's see. Minus cos upper limit 135 degrees, minus into minus plus cos 90 lower limit, and this by root 2, minus delta no 135 degrees minus 90 degrees, but this is in what? Degrees, but you should substitute in what? Radians. Okay, but careful, this should be in what? Radians. Anyway, at the end we will do that, no need to worry. But we know that what? Cos 135. Cos 135 is what? Cos of 90 plus 45. Cos of 90 plus 45 is what? Minus sin 45. Sin 45 is what? 1 by root 2. Yes or not? So 1 by root 2 I'm just writing here, minus into minus plus 1 by root 2 by root 2, 1 by 2. Anyway, cos 90 is 0, forget about that. And then 135 minus 90, that is 45 degrees. In radians, it's a pi by 4. Okay, so we get what now? Minus pi by 4. Clear? Just, yeah, 1 by 2 minus pi by 4. Okay, there is a small correction because 0.5 is there. Okay, so I need to take that. This multiplied with what? 0.5. So 0.5 will carry here. So that means 1 by 2 minus 5 by 8. If I solve this, we'll get 0.107. Okay, so 0.1073. Yeah, 0.1073. Okay, but overall this thing multiplied with what? P max. I just taken that common, right? So everywhere that is carried. P max, P max. So, but the answer we need to enter is what times of P max? That is 0.1073 times the P max. So this is the answer for the question. Okay. So we have divided the problem into what? 3 parts: pre-fault, during fault, post-fault as per the data given, and then we proceed the question. But the tricky thing is here, he is asking the acceleration area, but he has not given during fault power angle equation. But in the question, it's clearly mentioned critical clearing angle. For critical clearing angle, acceleration area, deceleration area same. That's why instead of calculating acceleration area, deceleration area we are calculating, because these two values we directly know. All the 4 boundaries we know. To calculate the area, we need 4 boundaries. Here we know all the 4 boundaries. Okay. So now we'll move on to the next question. Now, let's see this question. So, this question on ring main distribution system is asking to calculate, so which branch out of these 4 branches, which branch we need to open such that which gives a minimum power loss. So since we have only 4 branches, better to do the question, since it's a 1 mark question, you can directly answer, but if you have any confusion, means what? Just open branch 1, let's find out the loss. Open branch 2, let's find out the loss. Open branch 3, let's find out the loss. Open branch 4, let's find out the loss. Then you see in which case the loss is minimum. Okay, it will not take much time. Let's see. For example, if I open the branch 1, first of all, let me write the impedance of all the 4 branches. Clearly, it's mentioned. Branch 1 impedance is 4Z. Branch 2 impedance is what? Z. Branch 3 impedance is 2Z. And branch 4 impedance is 4Z. Now, let's see. Suppose if I open the branch 1, let's see what is the total power loss. If I open the branch 1, the circuit will be simply like this. This is I, this is I. I is what now? The current drawn by the load. All the loads are drawing the same currents. Now tell me, what is the current here? The current here is what? I. The current here is what? 2I. The current here is what? 3I. Right? I, 2I and what? 3I. Okay? Reverse. I'm sorry. Yeah. The 3I direction is reverse now. Now tell me, what is the power loss here? Now in this case, the branch 1 open. What is the power loss? I square Z. I square, but what is here? 2Z, not Z. The impedance here, it's not Z, 2Z. I square 2Z plus 2I whole square 4Z. 2 square will be 4, 4 into 4, 16. So I hope I can directly write 2 square 4, 4 into 4, 16, 16 into I square Z plus here what? 3I whole square. 3I whole square will be what? 9I square, okay, into Z. So directly 9I square into Z. So the total power loss will be what? 27. 16 plus 9, 25 plus 2, 27 I square Z. So this is for what? Branch 1 open. Okay. Now let's see. You can open the branch 2 now. Okay. We can get the different answer now. Clear? So just remove this circuit now. Now if branch 2 open, then this is open now. Okay. So the current here is what? Now I. Again, I am applying simple KCL to calculate the currents in every branch. I here, I. These are the load drawn currents. Then this will be what? 2I, and this will be what now? 3I. It's a simple KCL. The current here is I plus 2I, 3I. here current here is I, as it is the current is coming here, then the current I is added here, so 2I plus 3I. Now you can see if branch 2 open, what is the power loss? Now directly again starting from here, 3I square into 4Z, 3 square will be 9, 9 4 ja 36, 36 into I square Z plus, let's see what is the loss here. Second one, 2I square means what? 2 square will be 4, 4 into 2 8, 8I square Z plus the third one here, I square into 4Z, 4I square Z. Now what is the power loss here? 48 I square Z. So B2 will be not be the correct answer. Why? Because the power loss in the second case is greater than the power loss in the first case. Okay, similarly we can do by opening what now? Branch 3 now. Okay, if I open the branch 3, then what? Let's see what happens. Branch 1 here, branch 2 here. Okay, this is the branch 3 I open now. Okay, now the current here is I, and this current is what now? Let's see. Yeah, the load current here is I. So the current here is I, no doubt. The current here is I. But the current here is I means what? The current here is also the current here is I. So these two currents are added so that the current here is what? 2I. Simple KCL. Okay. Now what is, if you open the branch 3, the total power loss? Let's see. I square into what? Impedance is 4Z. 4Z plus here I square into what is the impedance here? Again 4Z. I square into 4Z. But here what? 2I square, 2I whole square into Z. That means 4I square Z. That's it, no? 2I square, 4I square into Z. So the answer is what? Yeah, 4, 4 plus 4, 12 into I square Z. Clear? If branch 3 open, this is the answer. Now, if branch 4 open, let's see what we, how the circuit and what is the answer we get. If branch 4 open, right, the current in this branch is I, the current in this branch is I, the current in this branch is what now? 2I. Now let's see what is the answer. Power loss. I square into Z directly. Then here I square into 2Z plus what is the power loss here? 2I whole square will be 4, 4, 4, 16. Yes or not? 16 I square into Z. So 16 plus 2, 18 plus 1, 19 I square Z. Yes? Yeah. I square 2Z, I square Z. Yeah. So this is the answer. Now you see where we have minimum losses. We can say directly from what? Branch 3 if you open. So the minimum power loss solution is obtained with what? When branch 3 is open. Okay. So the answer for this question is C. Okay. So I can say it's a bit lengthy approach, but 100% you will get the correct answer. Okay. Clear? So don't solve the question by seeing the impedances or by seeing any method you know. This is the best approach. Maybe it may take what? Some extra time. But if you are very fast in calculation, it may take what? 2 or 3 minutes, not more than that. I'm sure about this. Okay. So, but this is the best approach to answer this kind of questions. Okay. But similar kind of question already tested once in GATE exam. Okay. Now we'll move on to the next question. Right. Again, this question is from load flow analysis. Again, it's a very simple question. If you read the data, but in the exam, the people may feel that this is a difficulty question by seeing the data or by seeing the diagram. In the diagram, okay, j alpha x, j gamma x, j beta x given, that means the values are not given. Okay, whenever the values or impedance values or reactance values are not given, we feel that this question we can't solve so easily. But if you keeps on solving this question, keeps on reading the data, the question looks very simple. Okay, anyway, so in a 3-bus system shown below, the power flowing through the lines connected between buses 1 and 2 are 0. Straight away the power flow here is what? 0. Since it is a reactive network, active power 0 here, active power also 0 here. Sending end power, receiving end power 0. I am assuming the direction is what? Bus 1 to 2. Okay, even 2 to 1 also same. Okay, right. So the point is the power flowing from bus 1 to 2. Anyway, bus 1 to 2 only given, that's why 0 here and what? 0 here, no doubt. That means what is this P1? The power flowing here. Let's say I am assuming Px. What is this P2? The power flowing here, that is what? Py. Now what is the power drawn by this load? Px plus Py. That is the initial observation from the first line data. Okay, now if you see the second line, what is mentioned? Assuming the magnitude of voltage of all buses are 1 per unit. That means V1 magnitude, V2 magnitude, V3 magnitude is what? 1 per unit, clearly mentioned. And the load angle difference between any two buses are small. What is the meaning? For example, if I say bus I, load angle is delta I, bus J, where I and J are not equal, let's say, and this is what? Very small. Okay, we know that in power system, whenever we come across this statement called load angle difference between the buses are very small, then we can approximate it to what? 0. Okay, delta I minus delta J is what now? 0 here. Now let's see what is asking. If P1 equal to MP2, then which of the following relation is valid? So is clearly mentioned, P1 equal to what? M times the P2, then if P1 equal to M times the P2, then what relation is valid here? That's what we need to calculate. Okay, so but as I mentioned, the power flowing here is what? Px. The power flowing here is what? Py. P1 equal to Px, P2 equal to Py. But how to calculate Px here? Very simple. P1 equal to Px. We know the relation. If there is a two buses interconnected with a purely reactive network, we can go for simplified equation of what? V1 V2 by reactance into what? Sine of load angle difference between the buses. Yes or not? So let's say this bus voltage V1, that is 1 per unit, this bus voltage V3, that is also 1 per unit, reactance beta x into sine of delta 1 minus delta 3, delta 1 minus delta 3 is what now? 0. Okay, so sine 0 0 వస్తుందా? అవును సార్, 0 వస్తుంది కదా మరి. ఓకే ఓకే, ఐఎమ్ సారీ సార్, ఒక్కసారి సార్, చిన్న కరెక్షన్ ఉంది. Yeah. So we'll proceed now. So if the load angle difference is what, very small. Anyway, we'll write the equation for Px now. So bus 1 voltage is 1 per unit, bus 3 voltage 1 per unit, and what is the reactance? Beta x. And sign of sign of delta 1 minus delta 3 I need to write, originally speaking. But sign of delta 1 minus delta 3, what I can write now? What is the approximation? Sign of very small angle is what now? It's not 0. Sign of very small. If it is 0 means what? This P1 also we get 0. Finally, you will not get any solution. So anyway, sign of very small angle is what now? That angle only. So 1 by beta x into delta 1 minus delta 3, we get it. Okay. So that is the one equation. Now tell me, what is P2 that is equal to Py? Why? Because there is no power flowing here. The only power is what? Flowing here now. So P2 equal to Py, and that is equal to what? Again, bus 2 voltage into bus 3 voltage, and divide with what? Gamma x, okay, into sine of delta 2 minus delta 3, that is nothing but what? Directly I am writing sine of delta 2 minus delta 3 is what now? Approximately delta 2 minus delta 3. Now let's substitute here P1 equal to MP2. This relation is already given. P1 is what now? 1 by beta x delta 1 minus delta 3, that is equal to m times 1 by gamma x delta 2 minus what? Delta 3. Since he has clearly mentioned the load angle difference between the any two buses are very small. Very small means what? Very close to 0. That means what? This load angle difference, then this load angle difference I can cancel. Nothing wrong. Okay. Yes, I can cancel. Clear. Now tell me what I get here. Xx also I can cancel now. So what I can write now? 1 by beta equal to m by gamma. Okay. 1 by beta equal to what? N by gamma. So from this, gamma equal to m times the what? Beta. So that is the relation. So as per the given options, so D is that. Gamma equal to m times the beta. Okay, it's a purely based on the approximation what he has mentioned in the problem, that is the load angle difference between the buses are what? Very small. And we can't make it 0. If I make it 0, then P1 we get 0, P2 also we get 0, and there is no meaning of this question. That's why load angle difference is small. That means delta 1 minus delta 3, delta 2 minus delta 3, delta 1 minus delta 2, all are what? I can say equal. Okay, clear? So that's about the question number 42, and this is a 2-mark question and it's an MCQ question. Okay, so with this I'm concluding the power system session. So there is a one more question is there, that is from measurement subject. I will discuss that just after 1 minute. చెప్పలేదా సార్ ఆఫ్ చేసిరా? సరే ఇక్కడ ఆఫ్ అయిపోయింది వస్తుంది. Okay, now let's see, this is the measurement question given for 2 marks. So in this question is asking what is the magnitude difference between the, just hold on, okay, yeah, what is the magnitude difference between the wattmeter readings W1 and W2? Actually it is mentioned W1 and it is mentioned W2 in the exam. Okay, right. So if you want to calculate the wattmeter reading, you know the simple procedure, W1 reading, for example, if you want to calculate, or any wattmeter reading if you want to calculate, so you need to see what is the pressure coil voltage magnitude or potential coil voltage, voltage coil voltage magnitude multiplied with what? Current coil current magnitude into cos of phase angle between VPC and what? ICC. Now this is the fundamental formula, but in a 3-phase circuit this is very important to identify where the pressure coil is connected and where the current coil is connected, and what are the polarities of the coils. Let's see, the coil polarity is also clearly mentioned in this question. This is plus and minus, right or not? That means what is this voltage? R plus side, minus is from B side. So that means the pressure coil voltage of wattmeter 1, I am talking about wattmeter 1. What is the pressure coil voltage? VPC is nothing but VRB. VRB. Clear? Now what is this current coil current? That is the IR. The current coil current is what? IR. So ICC is what now? IR. Now what is the formula for wattmeter 1 reading? VRB magnitude into IR magnitude into cos of what? Angle between VRB and IR. Okay. Similarly, let's see for wattmeter 2. Wattmeter 2. What is the pressure coil voltage? Let's see. The pressure coil voltage is what? See, pressure coil is connected. Plus is on what? Y side, and minus is on what? B side. Correct or not? That means it is VYB. 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 Okay. And what about the current? Let's see, this is what the current. So plus current is what now? IY. So I need to calculate IY here to answer W2. So ICC is nothing but IY and VPC is nothing but what? VYB. So you need to determine VRB and VYB. But if you read the question carefully, it's a 3-phase circuit shown below and supplied from 400 volts 50 Hz. Actually it's a balanced supply. Yes, it should be given in the problem. It might be given, no doubt. Yeah, 400 volts 50 Hz balanced supply with RYB sequence. Okay. So if it is RYB sequence, better to say like this always in a 3-phase system. The first line voltage VRY, then what? After 120 degrees VYB, for RYB sequence I am writing. Then after 120 degrees RY, YB, and then what? BR. Okay. But to know VRB, VYB, so since this is what? VYB and VRB we need to know. So this is VBR, right? Where is VRB? Somewhere here. Exactly opposite to this. This is VRB. Now opposite to this is what? It's VRY means what? It's VYR. And opposite to this is what? VBY. Clear? Now the phase angle is what now? Between any two adjacent phasors, the phase angle is 60 degrees, 60 degrees, 60 degrees. Okay. Now generally we take what? The first line voltage reference. Since first line voltage as per RYB sequence means what? I can say VRY. You can take any reference, but I'm just taking what now? VRY reference. Okay. If I take VRY reference, what is VRB? VRB is what now? Line voltage. The magnitude of the line voltage is what? 400 volts. But what is the phase angle from the reference? This is after 60 degrees. That means what? At an angle minus 60 degrees. Very simple. I'll talk about IR later. Now what about VYB? VYB is what now? Yes, it lags the VRY. Our reference point is VRY. It lags the VRY by 120 degrees. So the magnitude is same at an angle minus 120 degrees. If you draw this wheel so that you can answer the question, you can you can compare the phasors, line voltages or phase voltages very easily. Okay. Anyway, so you got VRB and VYB. Then you need to calculate IR and IY. Okay. Let's see how to calculate IR and IY. So if you clearly notice the circuit, it's not a delta circuit, truly speaking, because here Z1 connected, here Z2 connected, but in between these two nodes, pressure coil is connected. Ideally, actually in the question, it might be mentioned that the wattmeter 1 and wattmeter 2 are what? They are ideal wattmeters. Definitely it is mentioned. Okay. So this pressure coil having an impedance of what? Infinity. That means better to say it is just an open circuit here. In the circuit point of view, this is what? This is how the circuit. Right? This is how the circuit. Simple. Now tell me, what is the current flowing here? What is the current flowing here? I need to calculate. Let's say I am assuming this current is what? Let's say some small, okay, better. I2, and this current is what now? I1. Now the voltage across this is what now? This is R, this is B, this is Y. That's clearly mentioned in the problem. This VRB. Z1 value given, Z2 value also given. Now what is this voltage? This voltage is what? Not VRB. This voltage is what? VRY. Okay. Now let's calculate I1. Now what is IR now? I1 plus I2. What is IY now? What is IY? Minus I2. IR is I1 plus I2. IY is what now? Minus I2. Let's calculate IR. IR is what now? I1 plus I2 from the circuit. Because we calculated the voltages, now we need to calculate the currents, then only we can calculate what? The wattmeter readings, then we can calculate the difference between them. Okay. So I1 plus I2. So what is I1 now? What is I1? So across this voltage is VRB. So VRB by Z1. VRB by Z1 is I1 plus VYB by Z2 is I2. Right? So let's substitute now. What is VRB? VRB is what now? Yeah, VRB 400 at an angle minus 60. 400 at an angle minus 60. And what is Z1 given? 50 at an angle minus 90 plus VYB by Z2. What is VYB? VYB. So anyway, it is there already. 400 at an angle minus 120 and divide with what is Z2? Z2 in the problem is 200 at an angle minus 30. Now if you solve this, minus 60 plus 90, 30 degrees, 400 by 50, 8 at an angle 30 degrees plus 400 by 200, 2, minus 120 plus 30, minus 120 plus 30, yeah, Z2. Just checking again, this is Z1, this is Z2, okay. So 400 by 200, that is 2, minus 120 plus 30, that is minus 60, minus 90, sorry, minus 90, okay, VYB. So there is a small correction. This is not, this voltage is not VYB, it's VRY. Check VRY, but I written here VYB. Please don't do this kind of mistakes in the exam. Yeah. So VRY by Z2. So what is VRY? Let's see again this wheel. VRY means what? 400 at an angle 0 directly. That is a reference. So 2 at an angle plus 30 we get it. Now 10 at an angle plus 30. Okay. Now tell me what is IY? IY equal to what? Minus I2. Because we should know IR, we are already done, and we should know IY, that is what? Minus I2. What is minus I2? I2 means what? This part is what now? I2. VRY by Z2. That means 2 at an angle 30. Directly I am writing minus 2 at an angle 30. So if you want to eliminate this minus sign, either you add plus 180 degrees to the angle or minus 180. Better to have an angle which is less than 150 degrees, sorry 180 degrees. So I'm just adding minus 180, so that I will get 2 at an angle minus 150 degrees. Now you have what? VRB IR and VYB IY. Okay, now you can calculate what is W1 reading and W2 reading by substituting what now. For example, if you want to calculate W1 reading now, 400 is the magnitude of the voltage and magnitude of the current is 10. 400 into 10, 4000. Cos of angle between them. So voltage angle is minus 60. Current angle is what? 30 degrees here. Okay. So minus 60 and what? Minus 30. So you will get what the phase angle difference is? Minus 90. So cos of minus 90 anyway what? 0. Just check once again. So 400 magnitude 400 into what? 10, 4000. Angle of this voltage is what? Minus 60 and angle of this is what? 30. But difference you are calculating now. So minus 60 and what? Minus 30, minus 90. So that means maybe you can get W1 reading is what? 0 and W2 reading you can calculate. Okay. But you can check it, you will get the answer. So this is how you need to answer this kind of questions. Okay. It's purely based on what? 3-phase circuit relations. Okay. So that's it. With this I am concluding this session. So with this I am concluding this GATE solutions, GATE 2024 electrical paper solutions. Thank you. All the best. Sir,